Okay, goats, cats, coffee, uh, testing, rhubarb, code of conduct.
Yep.
That work?
Volume, but yeah.
Do you want me to say more things? That's loud.
Yeah.
To see that one.
Hello. Hi, everyone. Welcome to the first and the biggest year of CSS Conf AU.
Yeah, sure.
One of the really big goals that we have here is challenging the quality of event that we run and inclusion, not only at the events here in Australia, but also worldwide.
And however, while we're globally focused, we also wish to acknowledge the custodians of this land, the Wurundjeri people of the Kulin Nation, and their elders past and present. I acknowledge and I respect their continuing culture and contribution that they make to the life of the city and this region.
So as I've said, it always has been our goal to build a series of events that not only expand your knowledge, but also, more importantly, focus on the human aspect of technology and the web.
And to us and our entire team, it's really important that everyone who's here in this room right now feels welcome and included. We operate CSS Conf under a code of conduct, which you can read about in full on our website. But the short version of it is that this is a safe place, free of harassment of any type for everybody. If you have any concerns regarding the actions of any attendee, speaker, or staff, refer to the website and chat to us.
So CSS Conf is a little bit older than the years that we've been running in Australia. It's a worldwide family of events holding each other to the highest standards that we possibly could. And we're incredibly happy to host some of our CSS Conf family curators here in Melbourne. We're really happy to have Christina Schneider of CSS Conf EU from Berlin and Thomas Garrison from CSS Conf Asia, which actually ran last week, so respect, Thomas, and he's coming to us from Singapore. So please give them a warm welcome, as we wouldn't be here if it wasn't for them.
And some of you may not know that one of the reasons that CSS Conf AU started was I myself attended Christina's conference in Berlin. And after a day or so there, I said, we have to come back and do this here in Melbourne. And so on my flight home, I drafted an email to the team, some of which are still working on it for the 9 months that we've worked on it this year. And I said, hey, let's try and run a really, really great conference. And it couldn't be that hard, so let's just give it a crack. And here we are 3 years later. CSS Conf is a not-for-profit. We're all volunteers. It's a labor of love, and it took us 9 months to get here this year, which is the longest that we've ever worked on the program. It's my pleasure to introduce you to the rest of the organizing team. So I'm Ben, Carolina, of course. And where is Glenn? I don't know, he ran. Well, Glenn's here somewhere, he's down the back hiding, I think. So we've got Glenn, Jordan, Michael, and Craig. Please welcome them. I didn't think you would come up here, but sorry, that was my fault. Yeah, no, you stay. So we have a professional photographer here today. Some of you may already know that because you have been given a lanyard of a certain color. If you're taking photos of anyone at the conference, just remember that the green lanyard means photos are okay, the black lanyard means please ask first, and the red one means, hey, just don't photograph this person. We have an official hashtag, which is #CSSConfAU. There are bathrooms in the back on the right-hand side. My notes just died on me, apparently. We have some really great meals here as well at CSS Conf. All of the food will cover all diets that we know about. It's really delicious, it's really healthy. We also have drinks down in a fridge on the left. Everyone have bagels this morning? Yeah, all right. We got coffee, we got tea, and we got some really great parties along the way. But if you have any questions, our catering staff will be more than capable of looking after you. So that's about it. I think we're good for now. Right, here's Glenn. Everyone, welcome Glenn. Thank you very much. Glenn actually said to me before the conference he didn't really like this part, and so I guess this is kind of fun for me. All right, let's get started. Just remember, everybody, this is for you. That's why we do it. I'm going to introduce our first MC, who is Christina, our organizer from CSS Conf AU, and she's going to take over from here.
Good morning, everyone. Whoa, what a beautiful view this is, seriously. I'm so impressed, and I'm very glad to be here today, coming from Berlin. And the team of CSS Conf AU says hi, and they wish you a fantastic day. And we've seen the team already, and I'm already so impressed by what they're going to put on here today for CSS Conf AU 2016. This is my first time coming to Australia, and I'm so pleased to bring you someone from my hometown, Berlin in Germany, who's actually a native Melbourne person. Our first speaker today, Ellie Long. Ellie works in Berlin at eHealth Africa. She's a designer and front-end developer, and there she's in charge of building interfaces that enable better public health services. That is, when she's not doing field research, driving in a jeep through West African countries and befriending baby goats. Goats are Ellie's thing, I hear, and I'm sure she's going to tell you a bit more about what's the deal with goats. But most importantly, Ellie is going to share her learnings and give us some insight and remind us of what's the most important part of our daily work, of the people who we are building the things we build for, our users. So please, everyone, give a very warm welcome to Ellie Long.
Hi, everyone. This is on, yes. Thank you, Christina, for that wonderful welcome. And thank you for the organizers. This is an amazing venue, and thank you for the glass of champagne. It's really taken the edge off my jet lag here. Okay, this is on. Now, in my jet-lagged state, I was kind of thinking about my talk title, How Novice Tech Users in West Africa Respond to Your Fancy CSS. And I kind of realized that it maybe sounds a little bit belligerent. It's definitely like a bit of a stank in there. But I am actually very excited to be here, and I don't want this to be a very strict lecture about what you shouldn't do. And I hope that at the end of this talk, you'll be as excited about making products for people in the developing world as I am. So hi, thanks for being here, thanks for having me. My name's Ellie Long. I'm Ellie-L on Twitter, and most other places on the internet. There's actually no goats in this talk, by the way. I think you've misled the audience on what to expect. So I'm a product designer and a front-end developer. And I haven't lived here for a while, but I do come from Melbourne. So I'm really, really happy to be giving this talk in Melbourne, because this is really where my career began, where my love of CSS began. But I've come quite a long way from home since then. So I worked as a designer and developer in Melbourne. I worked with a lot of great people, and we did really cool stuff. And I love CSS. I loved, when I started, figuring out the cool things you could do with it. And as CSS itself developed, I loved, all the effects and the animations that we could create. And then I moved abroad. I've worked in agencies in Berlin. I've worked at Eden Schwiekemann and at Color Bright. And in these places, we really kind of cranked up the cool stuff to a whole new level. And it was really, really fun working at these places. We did a lot of exciting work for a lot of exciting clients. And they wanted really cool stuff. They wanted the latest and greatest. They wanted the shiniest stuff, like the most cutting-edge stuff. We did a lot of work for Red Bull and Red Bull Music Academy, for Ableton, yours truly, Font Shop, and a lot more. So we did really great work, like creating these like really immersive experiences to delight their customers. But a few years ago, I changed direction a bit. Now I'm working for an NGO called eHealth Africa. So we get funding from organizations like the Gates Foundation, UNICEF, the Center for Disease Control, to work on programs, public health programs, and emergency outbreak response in West Africa. So the things that we build at eHealth Africa are very different from the kinds of things that I used to build for clients like Red Bull. The problems that we're trying to solve are not customer engagement or selling products. There are problems like the Ebola virus and polio, sleeping sickness, vaccine delivery, maternal health, and a lot more. So when I was working in agencies, field work used to mean like going to London for Red Bull music events. And user research was like hanging out with music industry people. Field work now is very, very different. It means piling onto the back of a motorcycle or into a four-wheel drive and accompanying teams of vaccinators and other kinds of health workers to really remote settlements in West Africa, visiting health facilities like this, which are very, very different from the kinds of health facilities that you find in Australia or in Germany. They're often, like 3 walls and no roof, no power, no electricity. They might have a working cold box for vaccines, and sometimes a small ambulance. So this context meant I needed to take a very different approach to designing and building products. This was really human-centered design to a degree that I'd never experienced before. So my focus really had to switch from how cool can we make this to how do we make this as useful as possible in what are sometimes very, very critical situations. So I want to quickly tell you a little bit more about some of the apps that we've worked on. So we were part of quite a few Ebola response initiatives. One example was an app that health workers used to keep track of people in Liberia and Sierra Leone. So we would keep track of people who had contact with people who had Ebola. So these health workers doing this contact tracing were an incredibly important part of this Ebola response. And their job was to travel from settlement to settlement, looking for and keeping track of anyone who had come into contact with someone who had Ebola. So these health workers, they used this app to follow up on people, to record their details, to record any symptoms that they might have, and their location. So this meant that we could pull in all this data. We could see the positions of all the infected people and all the at-risk people on maps. Another project we work on is to send out teams on polio vaccination campaigns in remote communities in northern Nigeria. So Boko Haram actually control a lot of the northeast of Nigeria, and they have declared polio vaccinations as a Western conspiracy to sterilize Muslims. So a lot of these areas are very, very inaccessible. But these teams of vaccinators would stop at every household that they could access. They would administer the vaccine to any children they could find. And we captured a lot of this geolocation data while they were at this. And we mapped out these previously unmapped, unknown areas. And we built a dashboard to see where the black spots were and where the resources were needed. We've also worked on programs to renovate health facilities in Guinea. So these are places that had no water, no electricity, a lot of very basic services, plenty of motorcycle parking sometimes. And we created a system to replace these paper-based books that they had, so that health workers there could report data about the kinds of diseases and incidences that occurred there. So that nationally you could know how many people had malaria or were showing Ebola symptoms, or how many people died and how many people were born. We also made an app that health workers use when they go out into the remote jungles of Democratic Republic of Congo, the DRC, and they would test people for African sleeping sickness. So this is a very easily treatable disease that's actually fatal if it is left untreated. So this app registers the details of the peoples in the villages, and it guides the health workers through this process of the various tests that they need to do to confirm a diagnosis. And we also created an accompanying dashboard app to analyze all this data that they brought back with them and to be able to plan where they send people. So I think you can probably see there's a bit of a pattern here. We do a lot of mobile apps that we send out with health workers to collect data, and we usually have a dashboard to accompany them to analyze this stuff. So what is the typical African user like? Well, there's no real typical user in Africa, just like there's no real typical Australian user. I've encountered people across a really broad spectrum of experience and level of comfort and knowledge with digital products. And a lot of people in West Africa are actually very, very comfortable using phones and computers and tablets and laptops, all sorts of digital interfaces. Uh-oh, Ben. My presentation's broken. Is Ben here? I might skip ahead to a few non-broken screens. So a lot of people are very comfortable. They have like multiple devices, multiple smartphones. They use like multiple SIM cards to maximize the amount of coverage they have on what are generally pretty shitty cellular networks. I actually had a taxi driver in Nigeria that had like 3 different phones plus a separate music device, and he was using all of them at the same time. I live to tell the tale. And you know, I have colleagues as well in Guinea who that are like bigger Apple fanboys, fan people, as I am. Hello. My images are broken.
Okay, I'll look.
So yeah, I certainly don't want to give the impression that that everyone in Africa is like confused by this shiny new technology. Maybe it was just a few slides that are broken. Cool. Thanks anyway. Thanks for nothing. Anyway, so the type of person that I do want to talk to you about, though, is like the novice tech user that we encountered quite a lot of these people on a lot of the projects I was working on. So these are people that had never used a smartphone before, never used a desktop or a laptop computer. There are people who had to go from using pen and paper to do their work to using an app. If they weren't completely new to it, then they were often relatively new to it. They were very recently introduced to digital technology. So they probably got their first phone at a place like this, at a street market, and it was probably something very cheap, probably secondhand, and probably also a knockoff, like just a fake Chinese BlackBerry. And they would have taken it home to their house that might not have had power. So they would have had to charge it via a generator or on a car battery, or they would have had to walk to a relative's house to charge it. Or maybe they had to pay someone who'd set up a charging station. So I think you kind of get the picture. I mean, we're making apps for people who live in a very different kind of environment to the one we have here. So I want to talk a little bit about how this kind of influenced our process. And we always had to kind of start with the sort of devices that we'd see. So smartphones usually look something like this. These Huawei Chinese phones are very, very common. And they often have, you can't see it too well in this picture, but they have like glare protection and often very rugged covers. They're almost always Android phones, and they're almost always very cheap hardware. So we have Huawei and Lenovo, LG. You do see some Samsung devices, but they're like higher end. And Apple or iOS devices you see very, very rarely, but very occasionally. They're quite a status symbol. So you get some real workhorses. You don't see the many, like sleek, naked iPhones around. They often have very scratched up screens, or they're very protected. They have like these protection covers and big rugged cases. There's a whole box of rugged up tablets. They're probably not going to be connected a lot of the time. And this is either because there just is no coverage. There's very little coverage in remote areas of West Africa. And broadband's very, very uncommon. Or because the data is actually really expensive compared to in proportion to your average income. So where possible, it is really great to be able to build in some kind of offline first functionality. And this is where we always start with the work that we do. This was such an awesome picture too. They're going to be really hard to charge. So I'm sure everyone knows this particular feeling of panic where you get the 10% battery warning. Well, you can imagine seeing that low battery warning pop up, but the nearest place you can charge your phone is an hour's walk away. One of the health facilities that we renovated recently in Guinea, we put solar panels on the roofs, and when I visited them, every single one that had solar panels had a device plugged into every power point in this health facility charging. But it does take longer to charge a phone that way. So a generator will take maybe 2 hours to charge a phone. Solar panels it'll take twice as long to charge. It'll take 4 or 5 hours to charge. So if your app or your website sucks up battery life with some fancy bullshit, then you're going to make someone walk for an hour to charge their phone again. Now, we've always found that touch screens are easier for people to use than laptops. We recently trialed a program where we gave health workers laptops rather than tablets to do their reports, and it was way, way slower. So most people have been introduced to technology via smartphones, and using a laptop or a desktop with inputs that are very disconnected from the screen is very unintuitive, very slow to type. So what you actually see on the screen. If it's not on the screen, then you're in trouble. Now, I know you probably all thought that we'd moved on from this, everyone knows how to scroll kind of thing. People don't know how to scroll. It's actually a really unintuitive thing for novice users. So anything that's off canvas, anything that you have to scroll for, off canvas navigation, these sort of patterns are very, very difficult to use. So I want to take this example. This is dummy content based on an actual app that we have in use. It's quite a simple form. It asks for some rudimentary identifying details for a person, but it's quite deceptively simple. How do you know that there's more stuff below the edge of the window here? Where's the button to go forward or to go backwards? And we only know this stuff because we just know it. It's obvious. And it's only really obvious because we already know it. We've had years of evolution of digital interfaces to get used to this kind of stuff. And this doesn't even show any validation errors, which brings up a whole new level of complexity. And with every validation error, people lose confidence and they get frustrated. So an alternative method, one that we've had some success with, is to get people to input data in a sort of wizard-style interface. So one main thing per screen. And this seems a bit tedious to people who are very comfortable. It might seem a bit slower. But, we'd much rather have more tech-savvy people complain about it being a bit tedious than to have novice tech users have no idea how to use it. So we broke down the interface to one main task or action per screen. So you ask for a name, and then you're asked for a date of birth. It takes a kind of form of a question and answer style of interface. It's a much more natural sort of mechanism. And we wanted to get people doing things with as little training as possible, so that people are focused on their work and not on learning how to use an interface. And on a similar kind of note, a avoid concealed elements at all costs. So the prime example here is a select tag, which there's a lot of stuff hidden here. This is really not great resolution, but so this is a very common kind of task for us. Health workers go out to a location and they have to choose, they have to tell the app where they are. And this is usually has some kind of hierarchy, like a province, a zone, an area. And the most obvious way to do this is to have select tags. And then that populates the subsequent select tags based on what they've chosen before. But it's very confusing. All of this stuff is then hidden away behind things that you have to click on or tap on. And changing a selection further down the tree means that it resets all of the stuff that you've already input. And a lot of people all over the world have trouble with select tags. This is really not specific to West Africa. So this is the alternative that we came up with. So this is an app. This is 3 separate screens in the workflow. And we ask them where they are, and we show them all the possible options. And we use very clear labeling to tell them what to do. We say tap on the option, on the place where you are. That's it in use. It's really important to have really good affordance. So if things can be pressed, make them look like they can be pressed. These real-world metaphors really help people understand how to use an interface. So, make a button look bigger and clickier, and if it looks slightly raised, like it has shadows and it stands out in an otherwise flat screen, this really suggests the idea that people should push it. And language as well really plays an important part in guiding people through these interfaces. It really directly communicates that you can click on something, tell people what to do. And combining icons with very descriptive labeling is also very helpful. So you can see the difference here between these 2 buttons. We've become very conditioned to accept this button on the left as a button. This is a very kind of popular flat UI style button. But a lot of people don't have this conditioning, and to them, this button on the right looks like something that they can press on. Looks very, very obvious. And speaking of clicking, people will probably click on everything just to see what it does. And particularly in a flat UI, pretty much everything looks like it could be a button. So people will press on everything just to see what it does. So it's generally a good idea to build in some sort of undo actions or warnings, confirmation dialogues, particularly for destructive actions like this. So if someone presses on delete records, then give them a very clear idea of what will happen. Give them an option to go back. Animations are actually really interesting because they can go either way. Sometimes they can really hinder a user's actions. So especially when it comes to inputting data or completing tasks. This is an example of a UI, material UI form element, which is very commonly used on Android now. And it has some really fantastic documentation on how to use motion and animation to show how an app is organized and what it does. But it really fails when it comes to form inputs. So these focus animations really in no way hint at what should happen when you complete this gesture. It doesn't depict the natural movement, inspired by forces in the real world. This is, certainly not what happens when I use a pen and paper. And where animations actually really shine is where they describe a spatial model, where they tell the user if they're going forwards or backwards or up or down. So this, for example, is there's a static kind of transition between 2 screens. You hit continue and you go to the next one. Something that actually really helps people understand where they are in an app is just a very simple transition element, so they're going left or right. Consistency is really, really important. If you have UI and navigation elements that are generally in the same place and act the same way, then they're going to really help people just learn how to use your app by memorizing it. And in this way, even people who are not very literate, maybe not literate at all, or very low literacy, they can often use these apps just by rote memorization of where things are and how they work. So if you use a forwards and backwards pattern here, like at the bottom, forward and back, then don't disturb that pattern in a different place by putting a back action somewhere else. And don't be afraid to inject a little bit of fun. I mean, I wouldn't go so far to call this gamification exactly, but giving users a sense that they're achieving something, that they're making progress, is you can really have a little bit of fun there, I think. You know, when we're asking people to register the details of like thousands of people, some sense that they're getting somewhere with that is really, really helpful. And if you're ever in doubt, you can always steal or borrow. There are certain apps that pretty much everyone in Africa is using. There's no surprises here, the Facebook and WhatsApp and Gmail. So if you're in doubt, you can look at these apps and look at the navigation and the UI patterns that they use and emulate them. So nearly every health worker that we provided with a phone or a tablet, they either immediately or eventually proceeded to download WhatsApp and Gmail and Facebook. And Facebook really knows that this is sort of where it's at. They know that this is where the next billion users in the world are. Their Messenger app already has over 1 billion users, and their Messenger Lite, which is the lightweight version that uses less data and sucks up less battery life, they're really aiming for the next billion with this. So the projects that I've shown you today, they're in a very much a public health context, but the lessons from this are not limited to that context. This is really where the next billion users are. These emerging economies present a huge opportunity and huge new audiences. And I mean, like everyone else in the world, African consumers are very demanding and informed once they become familiar with the technology. And despite being relative newcomers to this kind of digital technology, they want the same things. They want clear, reliable, very smooth running mobile solutions. And the things that matter to us here, in Europe and in the US, these same things matter to the people in Africa as well. They just have to be much more creative about how they access it. So they want to communicate, they want to connect, they want to listen to music, they want to take photos. I've never taken so many selfies as when I've been in Africa. And these resource-constrained environments, as they're called, they can teach us a lot as designers and as makers. They teach us to strip back everything to what is really, really essential. They teach us to know our users and to try and make things that are really useful to them. Things that you want them to be able to use and to be able to enjoy, and not what you think is beautiful or cool or shiny. And you don't have to go to Nigeria or to Guinea or to the Congo to discover this or for it to be useful to you. These are just the basic principles of good design: to have empathy, to have curiosity. And this is just a very exacerbated context here, but we're all human and we all want the same things. Thank you for listening.
Thank you very much. That was amazing. So next up we have Alli. So what's better than one Alli? Two Allis. Alli's going to be talking to us about accessibility. She's come all the way from Washington, DC. So could you give her a welcome? So, Alli's got a cat named Ada, so if anyone knows that reference, I thought that was pretty entertaining. She, I think also, I should let you know that Australia is actually accepting political refugees from the US at the moment. So yeah, I think that this is a really good connection to the previous talk because novice users, and accessibility is really useful for novice users as well. So I think this is a good segue into that. So round of applause again, and we'll get started.
Thank you. Can you all hear me? Is this on? All right, awesome. Presentation is working. 1 second, I gotta get my notes. Okay, yeah, so just as the title says, I'm here to talk to you all about accessibility, why it's super important, how we're dealing with it where I work at Vox Media, and I'm also going to leave you with some tips, so hopefully you can start implementing it in your work. And like he said, I'm Alli Palanzi, your second Alli of the day, and I'm a front-end engineer at Vox Media, working on our platform. And that's my Twitter if you want to follow me. I post a lot of pictures of my cat. And then also, if you need to follow along with the slides at all, you can see it at this link. So how many of you currently include accessibility in your workflow? Okay, that's awesome. So hopefully a lot of you are familiar. So accessibility, or A11Y, or Ally, or Alli, if you want, refers to the design of products, devices, services, or environments for people who experience disabilities. In 2001, the World Health Organization redefined disability as a mismatch in interaction between the features of a person's body with the features of the environment in which they live. As designers and developers and people who make stuff, our work can create or remove these mismatches in interaction. We're in a really cool place working on the web because the impact of disability is radically changed. The web removes barriers to communication and interaction that many people face in the physical world. So it's a really cool place for us to be in, and we can really help people this way, just like the last presentation. And by designing with disabilities in mind, we create better products for everyone. It's really important to not think of disability as something that only affects a subset of users. It's not something you can really tell from your analytics. You can't see who's using a screen reader. There's really not a great way to see if users are tabbing through your website and only using keyboard navigation. So it's really important to think about everyone and thinking about including this all the time. And to not just think of disability as something that affects people permanently. Disability can affect anyone at some point in their life. Microsoft Design built out extensive and really fascinating guidelines on inclusive design. In it, they show the different states of accessibility or of disability, and it can really be all over the place, so we need to plan for that. Disability can be permanent, it can be temporary, situational. A user who might be using your website with a mouse one morning could have a baby in their arms later that night and might only be able to interact with it via the keyboard. So that's kind of a situational disability as opposed to somebody who might have a broken arm. So I get it. It can be really hard to advocate for accessibility in your workplace and build in the extra time to make sure it's important. But you've really just got to trust the facts. Analytics aren't going to show you that you're doing better, but it'll be better overall for your users. And it's better for business. Building accessible products will improve a lot of things, and a lot of the thinking about accessibility feeds into other web best practices that you are probably familiar with, like device independence. Things should work across different browsers. They should work across different devices. Your product should be usable for all types of users, older users who may not be tech savvy, or even people in other countries who might not be as tech savvy as we are. And then, of course, a word that all executives and clients like to hear, SEO. If a screen reader can access your site properly, so can Google's indexing. And case studies show that accessible websites are just better overall. They have better search results, they have reduced maintenance over time, and increased audience reach. And accessibility supports social inclusion, allowing us to hire more diversely and reach a diverse audience. And then there's, of course, scary legal things. So companies like Netflix, Sweetgreen have experienced lawsuits for having accessibility issues. Things like creating internal tools that employees are required to use to get their job done, if inaccessible, might mean that you can't hire as diversely as you should. Or it might mean you're disadvantaging disabled employees to do their job. This is really important for us at Vox Media because we create tools for our reporters to publish content and get news out into the world. And if we can't hire diversely, then we don't get those diverse voices. And many countries are recognizing and acting upon the need to ensure access to the web for people with disabilities. The common approach throughout the world is to adopt the Web Content Accessibility Guidelines, which is developed through the W3C process and explains how to make content more accessible to people with disabilities. In the US, we have something called Section 508 of the Rehabilitation Act. So basically, it's a mandate for government agencies and federally funded nonprofits, colleges, schools, that they need to pass a certain level of accessibility, or they can get sued, they can lose funding, bad stuff. And in Australia, the World Wide Web Access Disability Discrimination Act Advisory Notes, which is a lot of words, requires equal access for people with disabilities where it can be reasonably be provided, which is similar to the US 508 compliance in that mandates like governments and banks and education sites to be accessible. And then for the European Union, the EU Charter of Fundamental Rights, Article 21, prohibits discrimination based on the grounds of disability, among others. So if your site isn't accessible, it can be seen as discrimination. And then more, obviously I wasn't gonna go through all of the different countries. Everything is slightly different. So it's really important to be aware of the accessibility laws that pertain to your work. And if this somehow still doesn't convince your project stakeholders or project managers, just do it. Ask for forgiveness later. It's really not that complicated to build accessibility in, and no one is gonna be mad at you for making your products more accessible, hopefully. So, like I said, there's a lot of reasons to care about accessibility. And at Vox, we've grown a lot over the past few years. I think when I started, the product team was about 40 people. Now we're up to 150, and the whole company is probably close to 1,000. So we're building lots and lots of things for our colleagues and our users, and it's not really something we've ever really started to consider. We didn't really start until earlier this year, in May. But we're already seeing big changes across the company. On the product team, we've always had advocates for accessibility. One of my coworkers created an accessibility channel in Slack, which is how you know it's official. So it was just kind of like a group of maybe 10 of us who would drop in links and share knowledge, and it didn't really go much past that for, I guess this was created in 2015, so for over a year. And we talked a lot in there to try to figure out how we could start including accessibility into our workflow. And at Vox, we have this yearly hackathon where the product team gets together. We're very remote, so we come into one place, and we have a hackathon where we can work on whatever we want. It's called Vox Hacks. And we can work on anything. I think somebody made an app this year that sends you GIFs of puppies every day. So it can really be very broad. And this is really successful. So we also have this thing we call mini Vaxes, which is where like a small group of people get together and can just kind of work on whatever they want. Our managers are pretty lenient about approving whatever. Not whatever, but reasonably. So I think 6 of us decided that we wanted to do like a mini hackathon to kind of scope out and figure out how we could all start including accessibility into our workflows. So we spent 2 days. Realistically, we all couldn't take too much time away from work to think about this, and we kind of wanted to time box it. And we knew we wanted to get some sort of training, so we asked someone from this agency in DC called Viget, and one of their front-end engineers came up to our office for a day, talked about all things accessibility, which was really, really helpful to see how they were including it into their process. So we spent 2 days brainstorming, we had a speaker, we wrote a whole bunch of documentation, and then we spent a lot of time planning how we would start spreading this across the company. So So this is a screenshot of our Google Docs folder just for like our final documents. We wrote a lot of docs, I think there's 6, and we kind of broke it up based on role. So we have a document for engineers, we have a document for project managers, we have a document for quality assurance, designers, editorial, to make it a little bit easier to spread it across the team, and that way we wouldn't just like overload people with a whole bunch of documentation that would be really difficult for them to parse. And then with all of that, we also kind of came up with some guiding principles to help us frame like why we care about accessibility and why this is really important to us to consider and think about. So the first one is people want to access our content and use our tools. Let's make it easy for them. We don't make assumptions about our users. As I mentioned before, it's really difficult to tell what disabilities may be affecting your users. This is where the industry is going. Get on board or get left behind. And then accessibility is everyone's responsibility. This is important because we didn't want the 6 of us to just become like the accessibility police. We wanted to ensure that everybody understood the importance and wouldn't just expect us to call them out. We wanted everyone to really care. So this turned out to be really successful. We spread them around to our team. People read them, people loved them. We wrote best practices for editorial on our internal documentation website that we have. We ran knowledge shares and gave presentations to any team that would listen to us, and we shared it on our blog so that other companies could use it if they wanted. And we began to incorporate it into every single project. So this screenshot is an example of the Verge redesign, which was happening earlier this year, and the team that worked on that laid this out early on, like when thinking and picking about brand colors and things like that. And then probably the hardest part is trying to figure out how to keep people accountable. So one of the main things we came up with when we had that little hackathon was to start integrating our accessibility into our quality assurance process. So we met with our QA managers and our support managers and talked to them about how we could like start testing for this stuff. We started treating it as other features in a project. So just as your requirements checklist, we added accessibility stuff in there too. And then celebrating wins. So for example, for the Verge redesign, which launched in March, we like called out like this was designed through a lens of accessibility, and this was like really thoughtful and important to us. So since we had all these internal successes, we wanted to figure out how we could share this with the world and figure out like how we could get other like open source contributions from other people, and like we figured that this was really useful for us, that it could be useful for everyone else. So luckily for us, we had that hackathon, which is every summer. So it was just a few months after. This was in July. So we spent 2 days fleshing out the guidelines and kind of figuring out how we wanted to share it. At first, we were just going to release all the documentation in some small open source website. But then we started to try to think of like how we use the documents and like what the best vehicle for that is. So we created this site, accessibility.voxmedia.com. Oh, yeah, this is a GIF of the site, kind of. So one of my teammates had started including accessibility checklists in each of her projects. So she would list out like what the engineer would have to do and would add accessibility things for them to think about to that. And things like for the QA people, like, and add accessibility into that. So because of how she was using these docs, we thought that making a checklist builder would be helpful for other people. So we have the site divided up into the same sections that we created for the documentation: designers, engineers, project managers, QA, editorial, and it allows you to select the items relevant to your project, and that puts a list for you to copy. It also includes a bunch of links to resources and tools. And this was, like, people liked it, and I think people use it. I hope people use it. We got a bunch of open source contributions, and it's been really helpful for us. So that's pretty much the story of how we got it like started at Vox Media. And now I'm going to hopefully give you all some practical advice that you can start using. So this is accessibility best practices for designers and developers. So this is an important one. Make sure there's enough contrast between the text and its background color. There's tons of tools to help figure this out. You don't have to just guess. And there's standards for it. Don't indicate important information using color alone. So this example is if you had a link in text and you just had the link a different color, or low vision users or people with color blindness won't even notice that that's a link. So adding something like an underline or maybe bolding it would help with that. Pairing values of color, not just hues, to increase contrast. It's always good to look at your stuff in black and white occasionally, just to kind of see. There's also tools for colorblind simulation. Designing accessible forms. This was kind of brought up in Alli's talk also. Making labels very clear, having error messages that are very clear, not just using color. Very confusing and frustrating when you fill out a form and get an error but don't know why. And then from that, just building accessible forms. Always have labels for every input. Don't use placeholder text instead of a label. Labels shouldn't disappear on form focus. And then make sure to use field set and legend for larger forms. It's helpful for if users are using a screen reader and other assistive technology. Then use semantic HTML. Luckily for us, HTML is semantic by default. You kind of have to go out of your way to mess it up. Try not to nest unnecessarily elements like div inside a div inside a div inside a div. Like sometimes it's necessary, but it makes it a little more difficult for assistive tech to like parse the information. Use headings H1 through H6 for content structure. Avoid skipping headings in the same section. And then it's okay to have multiple of the same heading on a page. Just it's better to not have two H1s in like your first section. I think it used to be an SEO thing to not have more than one H1 on a page, but I don't think that holds true today. And HTML landmarks. So these help define specific areas that a user might want to seek out and can save them a bunch of time. So for example, if you're using a screen reader and need to skip to the navigation, this helps with that. The HTML5 elements like header, main, nav, footer, aside all have these built in, but if you're not using those, you can add role, banner, role, navigation, etc. To add that in. This is a pretty simple one. Your document should have a language attribute. This is good for SEO and screen readers just to know what language your page is in. Focus states. So you should absolutely never remove focus states from any of your buttons or links. I think the original CSS reset from Eric Meyer, like the first one, had this set to none, and so people just never overwrote it. It's since been updated. And then if you don't like the normal blue, you can kind of see it up there, focus color, you can design better ones, or you can just leave them as is. And then they should never be subtle, they should stand out. Users should be able to tell what item they're tabbed to and what they're focused on. This is, oh, you can't even really see it up there. But, so on Google, for some reason, their search field doesn't have that blue focus state, it just darkens the drop shadow a little bit, and this is a great example of, like, that's not noticeable at all. And they really should have just left that blue glow. Knowing when to use buttons versus links. Linking to something outside the page, you should use an anchor tag. If you're performing an action on the page, like submitting a form, you should use a button. These are used differently with keyboards and screen readers. And then making links descriptive. If you just have a link that says click here, it is difficult for if the screen reader pulls out all the links on a page outside of the context of the text. Click here does not make any sense. And it's also really helpful for SEO to have descriptive content connected to the link. Should write good alt text for images and hide decorative images and not have bad alt text. So this is helpful for if your image doesn't load, this text is what will show up in its place. This is how non-sighted users will get descriptions of your images. And then if you have decorative images like a border, for example, you can add an attribute aria hidden, true, and that'll just hide that from people with assistive technology. Then accessible inline SVGs. So SVGs are used as icons, interactive elements. They should have a title or description, and then you can use aria labeled by attributes to tell the screen reader what element to use to describe the SVG. So this is an example of a green rectangle, probably not the most useful SVG, but it is labeled by the title. So if a user is using a screen reader, that's what they'll hear. And if an experience can't be made accessible, then create another route for assistive tech. Not everything is easily made accessible, so if you have like a really complicated interactive chart or graph, something like that, it might be better to have like an HTML table displaying that data, but just hidden on the page, but in the markup still, so that screen readers will still access it. As long as you don't display none on it, a screen reader will still pick it up. Allowing for viewport zooming, so a lot of people add this to their sites, so you can't zoom in or on your iPhone or on your desktop, which is really difficult and really obnoxious. And then supporting keyboard navigation. Users should be able to tab through your entire page. Don't allow for keyboard traps. If someone gets stuck somewhere on a page, they should always be able to like back out of it. This happens a lot with modals and things like that. You enter into a modal and then there's no way to like tab to click the button or exit, and it's really annoying. And just to remember that accessibility is everyone's responsibility. If you're a developer and getting inaccessible designs, don't hesitate to push back on them. Remember that semantic HTML goes a long way, and don't change default semantics. Don't make a link act like a button. All right, it sounds like kind of a lot, so testing it is very important. So some best practices that I use in every single project is first I start with navigating the page with my keyboard, making sure I don't get into any of those keyboard traps. I try to do this early because it's a lot more difficult to come in after the fact and fix this. Adding accessibility to your project checklist just as you would any other function or feature. And then including accessibility in your browser QA process. And like I said before, testing early and often is key. So one of my favorite tools to use is this Alli bookmarklet, totally bookmark it. This basically, you just add it to your browser, click on it, and it'll show an overlay on the screen of all of the things wrong. This is an example of one of our sites at Vox Media, which is not perfect by any means, but you can scroll through it and click on the different things, and it will show you what isn't accessible and give you examples of how to fix it. It's really helpful. This one's good for as you're designing things, color contrast analyzer. I think it's a Mac app, but there's lots of tools like this online. So you can just paste in your color choices and it'll tell you if it's accessible or not. So that was kind of a lot of stuff. So to recap, disability affects everyone at any point. If you have trouble getting buy-in from executives and stuff, ask for forgiveness later. Just kind of do it if you have the time. It'll benefit you in the long run. And then baby steps count. It's not going to happen all at once. So we've been at this now for a few months, and that screenshot of kind of inaccessible curbed is still out there. Thinking about accessibility early and often is very important. Semantic HTML and browser defaults go a long way. Don't overwrite how the browser already works. And in general, let's just make our work better. So, thanks.
Thank you so much. Can I get... Oh, that was me. Thank you. Thank you so much, Ellie. Can we have a quick show of hands? Who of you is here at a CSS Conf for the very first time? Whoa. Well, extra special welcome to all of you. Unfortunately for you and also for the CSS Conf veterans, there's bad news. That was it with the Ellies for today. But I promise you, there's going to be way more great speakers after a 30-minute break. For all of you who didn't get a chance to get coffee or tea, that's your time now. I hear we also will have super tasty and healthy snacks. So see you back here at 11:40. Thank you.
Check. Test. All right, thank you, everybody. Hope you had a good break. There's a lot of people here. I'm competing with a lot of noise, so hopefully we can get started soon. As many of you may know, my name is Mark Dalgleish, and I'm very pleased to be here to introduce our next speaker, Michael Rogg, who's joining us all the way from Houston, Texas, where he runs a small dev team. But interestingly enough, he earned his Texan stripes by at one point selling and restoring cowboy hats at a century-old hat store. I thought that was very interesting. So he's here today to talk to us about a really interesting project out of Google, accelerated mobile pages, dealing with some of the real performance issues that we have on mobile for the web. And so without further ado, please join me in giving it up for Michael Rogg.
Howdy. Good morning. Aussie, Aussie, Aussie. Okay, there are some people here. I'm extremely honored and pleased to be with you. It's my first time to Australia, and so far it's been awesome. I'm excited to meet all of y'all and to learn with you and learn from you this week. Quick shout out to the organizing team. We're like 2 hours in, and I'm already just convinced that this is the most thoughtfully organized and prepared conference that I've ever been a part of. So Ben, Glenn, Carolina, Craig, Jordan, Michael, everybody, all the volunteers, let's clap it up for them, because this is... Y'all have done very well by your community, and I'm grateful that you had me here. I am Michael Rogg. This is my email address. This is the website where after the talk I will put all of the resources and citations and further reading links. I do hail from Texas, the land of bluebonnets and barbecue, where all the web developers have cowboy boots and ride our horses to work. When I'm not crafting code, I like crafting cocktails and fancy food, and I like to swing dance, and I work out with the local circus, and I tell you all of this so that if you think the talk bombs, you'll still have a reason to be my friend in the coffee break. But please do check out this website, and my heart is broken because we have no QA today, but I love questions, so please, if you have questions and thoughts about this stuff, get in touch with me. I would love to hear from you. So we're going to talk about accelerated mobile pages, and when I think fast, I think the BE-4 rocket. It's the first rocket ever to take a spacecraft up into space and back down, setting it gently back on the ground, right side up. That's from Blue Origin. A good friend of mine works there, and when I think fast, that's what I think. I think I want the mobile web to be rocket fast. But before we talk about accelerated mobile pages, we need to address the underlying human motivation for why we care about making things fast. And that is that attention is the single greatest resource that we can possibly ask of someone. Attention, I define attention as intent applied over time, time being really, really valuable, as we all know. And because time is valuable, we need the content that we produce, the experiences that we produce on the web to be fast, especially on mobile clients, in situations where the device might not be as powerful or the network is not as fast, such as some of the stories that you heard earlier from Alli. The mobile web is really a sensitive area for performance, but it's also very important. 1 in 4 Americans only browses the web through their mobile device, and this, as you've heard, is greater in other parts of the world. And so we need content on the web to be really, really fast. So picture yourself for a moment. Everybody, close your eyes for a second. Picture yourself in your imagination in some place where your time is very valuable to you. You're at a bus stop, you're in between meetings, maybe you have definitely not pulled out your phone at a red light, but somewhere where you have only a little bit of time. And someone that you like has posted a cool-looking story to that social app that you use, and you think you'll check it out, so you give it a click, and you wait. And you wait. After a few seconds, the little progress bar at the top of your mobile browser is starting to make moves, so you have a little bit of hope. The background maybe changes color. Progress bar inching forward, and hark, some text appears, but it's kind of tiny. You can't read it. Your phone might be moving around. Maybe you're walking. But you're starting to read this text. You're determined. All of a sudden, the text disappears. But a second later, it reappears. It's a little bit bigger now and in a different font, and so you've lost your place. But again, you're determined, so you're still reading. It flickers again, and then some images start to appear. And with every image that appears, the text on the screen gets jostled around, but you're still trying to read, you're determined. And then an ad appears. And not just any ad, but a full viewport, interstitial ad. You know it's an ad, not because you can see the ad, that hasn't loaded yet, but you see the word sponsored content at the top of this blank white box, right? And you're a web developer. You know where this is going. The ad script is going to load an analytics script. It's going to load a beacon script. It's going to load a platform script. It's going to load another analytics script. It's going to load another beacon script. 50 scripts later, this is never going to load. And so you do the only reasonable thing, which is, in a fit of rage, you open your task manager and you swipe your browser into oblivion. And you feel defeated. Raise your hand if this situation applies to you on a regular basis. Open your eyes for the grand reveal. Now, hands up. This is a problem. It's a big problem. After 3 seconds, Google tells us 40% of your traffic drops off. After 10 seconds, you've lost everyone. You've lost 100% of your traffic, which is ironic because the vast majority of web pages take more than 10 seconds to load on a lot of mobile browsers. Swaths of the internet are not being seen at all for lack of resources and lack of patience. And in between these two data points is just a spectrum of pain and anguish, because we know that engagement is proportional to speed. The faster our thing is, the more engagement we're going to have. And so when somebody isn't getting your content, it's a lose-lose-lose. The publisher's going to lose, right? They can't get their content to their viewers, but they're also missing out on the user acquisition advantages and the monetization of that content. Platforms lose because a bad experience with an embedded page or an embedded experience spills over and causes bad perception in a UX sense of the overall app or the overall platform. So platforms are losing, but most of all, the user is losing. They're frustrated. At best, they hate you, right? And at worst, they hate you, and whatever you have asked their attention for, they didn't get. They feel defeated and discouraged. So at the heart of it, this isn't really going to be an accelerated mobile pages talk. At the heart of it, this is actually a web performance talk. AMP is merely the vehicle. It's the framework that we're going to use to talk about web performance because it gives us a lot of cool web performance out of the box and sets a lot of good examples for us. And that's why AMP is relevant and why you should be paying attention to this project. But at the end of the day, we care more about making things fast than we do about AMP specifically. And so as you're listening to this talk, I want you to get interested in AMP, but I also hope that we'll take some pointers from AMP that we can apply to the web at large. So we start with this three-point premise. First, the mobile web depends on performance. Good performance means good experiences on the mobile web. We also have pretty good best practices for making things fast, and they're getting better every day. We know how to make the web fast. And therefore, since we know that speed is important and we know that we can have speed, we have the technology to have the speed, then we also need systems for validating when things are fast and incentivizing developers, platforms, publishers, everybody to get on board and make the web fast. How fast? Well, Google tells us we really ought to shoot to deliver and render above-the-fold content in under a second. Now I know what you're thinking. You're thinking, how possibly can I deliver and render an experience in under a second? On a mobile page, the vast majority of the world still depends on 3G. Your best case round trip on 3G is about 200 milliseconds. That's a fifth of a second for the DNS lookup. It's a fifth of a second for the TCP connection. It's a fifth of a second for the HTTP request, right? That's just the network side stuff. Then you're going to spend, if your server can kick back a response in a fifth of a second, that's great, and that leaves you 200 milliseconds to render everything in an already compromised mobile phone browser. So this is going to be challenging. This bit, the network side stuff, we can't talk about too much today, but the server response and the client-side rendering, that's where AMP is really going to help us out. And so cue the angelic music. Google's answer to this is accelerated mobile pages. Accelerated mobile pages is Google's answer to this premise that we should have systems for validating and incentivizing a fast mobile web experience. So AMP is an open source project. It's a proof of concept. It's just over a year old as an open source project, and it's backed by some platforms and publishers that you may have heard of, like Google and Twitter and WordPress and BBC and others. It forces us to use good best practices, stuff that you may have heard of, and if not, we're going to put it on your radar today. Stuff like inline CSS and GPU acceleration and efficient font loading, prioritized resource loading. And it does all these things in order to guarantee that our pages meet a baseline level of performance. And then, underneath that, Google's going to give us some extra machinery for caching and pre-rendering and discovering that fast content so that we can prefer that content and do cool UX stuff with it. So AMP is a tech spec. It's a tool set that we should take a look at, but it's also a business opportunity for board members and product managers and anyone who asks you, hey, developer, I need one more analytics script on our page, right? This is your answer to them to say, no, we shouldn't clunk up our pages with all of this stuff. There is a better way, and that better way gives us advantages in a business sense, in a user acquisition sense, in a monetization sense, so that we don't get caught fighting things like user acquisition with things like web performance. And also, as I've said, it's a learning platform. It sets a lot of good examples. It forces us into bad habits, but it's also a study case that we can look at and take some concepts out to use, whether or not we are going to subscribe to the AMP spec specifically or completely. Whether we want to, whether we're able to, whether we care, there's still some good examples to be learned. So let's take a look at the parts of AMP. AMP has three major components. There's the AMP HTML, the AMP JS, and the AMP cache. The AMP HTML is the set of HTML elements, native elements, and some custom elements that form the spec. And just like you can validate HTML, you can validate CSS, you can validate anything that has a spec, you can validate AMP. So to validate AMP means that you are using the stuff that AMP says you can use and not using the stuff that AMP says you can't use. And so it's just plain Jane HTML with a little bit of sugar. Then we've got the AMP JS, and this is the JavaScript library that you'll include that will sort of validate and enforce the spec, but also bring it to life, instantiate all these components, and supercharge your AMP HTML. And then we've got the AMP cache, which is going to do some network-side stuff for us. So again, we're addressing the latter part of this crucial, valuable 1 second in which we're rendering stuff. We want fast server-side response, and then we want fast client-side rendering. So we'll first look at the AMP HTML. It looks, to write an AMP HTML document is no great feat. It looks like regular HTML that you're used to seeing. It's got the HTML doc type there up at the top. It's got a special attribute on the HTML tag, the AMP attribute, or if you're feeling frisky, you can use the lightning bolt emoji, and that's not a joke. You can actually use the lightning bolt in your HTML code. You've got to be using UTF-8 encoding because it's fast and it's consistent, and you don't need me to tell you that because you're already using UTF-8 everywhere. You need a canonical link because in some cases you will have your normal web page, and then you'll have the AMP version of that web page, and so you need a canonical reference back to the primary page, whether or not the AMP page is canonical. You need that link in there. And then, of course, we're including the AMP JS from the CDN. So we're including it from Google. It's very fast. And this will be the only script that is on your page, is the AMP script. Some structured data that takes the form of a script, like your JSON LD, is allowed, but you're not going to have any user-authored scripts. Then you'll have your styles, and you start off with the AMP boilerplate styles. And this is kind of in flux. It's subject to change a little bit, but right now the purpose of it is to help prevent that flash of unstyled content. So it's waiting on the JS to say, this page is ready, and then it's nicely revealing that page to the user, and of course there's no script fallback for that. And then we have your custom styles, and this is where you get to write your CSS, and you can write just about anything. You have to use simple selectors, but you can write your custom styles. And then, of course, you have your body, and in the body, you have most of your normal, content, your paragraphs, your lists, your headings. But you have some custom elements that AMP has substituted in for some HTML elements. For example, in place of a regular image tag, you'll have an AMP image tag. And the reason that AMP does this is so that the JS can have better control over the rendering process. So there's some cases where you'll just use an AMP element in place of your normal vanilla element, but of course it is still just HTML. And so then we animate this, we bring it to life with the AMP.js. The AMP.js is going to enforce that spec, it's going to keep us using those good practices. It'll also provide some dev tools, so if you have an AMP page and you tack on development equals 1 to the URL, then you get nice logging out to your browser console. It's pretty cool. And then the AMP.js does the magic. So what magic does it do? Well, async everywhere, that's very important. It makes sure that all the scripts and anything that gets loaded on that page happens asynchronously so that it can't clog up the render chain. It's also going to handle some DNS pre-connecting for you. So if AMP sees a component like, say, a Twitter embed or a SoundCloud embed, where it knows that something is going to need to eventually be loaded from a third party, it can prefetch that DNS so that you don't have to do that right when the user is trying to interact with that content. It speeds up the network interactions a little bit for you. It provides a static layout engine, which means that because in your AMP you will have, in your AMP HTML, you will have provided the specific widths and heights and aspect ratios of all of your elements, the layout is going to be independent from any media or content that needs to get loaded. That means that this layout can be determined only from the HTML, and it's immediately ready when the HTML loads the page. You don't actually have to load anything from a third party in order for that page to be ready for a customer to look at. So that's pretty cool. And then it also does some content prioritization stuff, which means it's going to take a look at where elements are on the page and what the user intent for those elements might be, and prioritize loading the content that a user needs to see or interact with first. So there are some limitations that are imposed by this spec. Like I said, you can't use any user-authored JavaScript. There are some ways around that if you're sitting here thinking, oh, but I want to start with an AMP page and then spin it up into a mobile web app, a progressive web app. Yes, you can do that, but that's for another talk. In a plain Jane AMP page, no user-authored JavaScript. And you have to use some custom tags in place of some normal tags, things like images or media, video, audio, stuff like that, to keep those elements subservient to the AMP.js rendering process. You do have to provide the fixed dimensions of your media, which you should be doing anyway, but that ensures that no third-party components, nothing needs to be loaded in order for that layout that static layout to render. And there are style sheet requirements. You only get 50 KB of styles, which is probably plenty enough to render a simple page on a mobile browser, and you have to use simple styles, so no star selector, because the performance characteristics aren't as predictable. So there are some limitations. That's the bad news, but the good news is it's guaranteed to be very, 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 very fast. And those custom components that we talked about aren't actually that limiting. There's a whole library. There's probably hundreds of them at this point, from every kind of media that you can imagine, images, videos, audio, stuff like analytics or ad blocks. So you can monetize AMP content, which is actually great because it will convert better for you on those monetizations because it's fast and the ads aren't getting in the way of the user experience. Interactive elements like carousels and accordions and lightboxes and user notifications and third-party embeds like tweets and audio and YouTube videos and stuff like that. So lots and lots of components. I don't think you'll find yourself limited if you start playing around with AMP components. And of course, the dev tools. So if you add that development equals 1 onto your URL, then you get a nice validator checklist and some informational messages in the browser console to help you as you go along. And then, to top it all off, we have the AMP cache. And I won't talk too much about the AMP cache today, but it's a proxy cache for AMP content. It's from this internet company that you may have heard of that is known for doing big, fast things. So the fact that it's backed by Google is quite a powerful statement. It means that CDN is pretty much everywhere. So going to be very reliable, very fast, and it works because AMP validates. So the AMP cache can be very reliable and very fast because you know, because of the AMP spec, that the AMP HTML is the only thing that has to load in order for that page to get rendered. You know that nothing is going to break by running this page through a CDN. And what that means is that when you're spinning up a page in a context where URL isn't really important, like in an iframe or in the web view of an app, like Twitter, you've clicked a link and you open up some web Chrome. Anywhere that a URL being pretty isn't so important, you can load that page from the CDN, and then you can leverage a lot of pre-caching and pre-rendering and pre-fetching stuff that AMP gives you for free. And that is going to enable the incentives that we talked about. Because we know that we can discover and access content that is guaranteed to be fast, we can create special experiences around that content, which incentivizes people to use it. So those are the three pieces of AMP. And if you wanted to see what it looks like in practice, you could actually do something as simple as a Google search on your phone for something maybe newsworthy. And when you search, you'll see this kind of carousel of news stories that pops up at the top, and they have the little AMP logo on them. And when you click them, they come up instantaneously. It's amazing. And not only does the first page load instantaneously, but you can swipe through that carousel and see all of the pages that were in that top stories carousel, and they all load pretty much immediately, which is pretty impressive. So how does this work? How are we able to achieve that kind of immediate loading performance? So here's where we're going to talk about some of the underlying design decisions behind AMP. And we're going to talk about how this makes AMP fast, but also, again, in the back of your head, I want you to be thinking, how can I take these examples and these best practices and make use of them whether I care about AMP or not? So we'll start with efficient font loading. So, the normal browser of your typical, the normal browser behavior on a typical page is you're going to download all the styles and apply all the styles and download all the scripts and run all the scripts, and maybe the scripts download some more files. And so after all of the styles have been applied, then the page is rendered. And at the first moment where a web font could be used because the page is being rendered, that's when that web font gets downloaded. So very, very frequently, we have a lot of assets in the critical path to rendering something like a web font. So AMP keeps that critical path clear, and it does that by asyncing all the scripts and by forcing us to use inline styles. And it makes sure that media gets loaded, pictures and videos gets loaded later in the render process than a web font that I need for above the fold content. So this is a bonus not only to actual performance, but to perceived performance, because the user isn't seeing those jitters and flickers. They just get a nice page presented to them relatively instantaneously. And so in AMP, you get this for free, but if you can't or don't want to be subscribing to the AMP standard, you can still defer and discard unneeded styles for later. Also, the inline CSS makes a big difference. So in AMP, you have this 50 KB block of styles that you can add to a page, which should be plenty. But maybe you're not using AMP. Maybe you're just designing a responsive web page. Well, you don't necessarily want to inline all your styles because we do want the HTML file to be reasonable and manageable and download quickly. But we want to prioritize rendering above the fold content. And so for any styles that are important, we want those to come across the wire probably with the HTML so that they can be rendered very quickly when the HTML file is downloaded. So there are some tools out there to help you do this. Anybody heard of Critical CSS? So Critical is this nifty tool. It's a command line tool, but it runs in Gulp and Grunt and all of your task runners. And it'll actually, it's super cool. It spins up your page in a phantom browser, renders the page, figures out what is going to be above the fold, pulls out all the style rules that are necessary for rendering that stuff, and generates you a little CSS snippet that you can inline with an HTML file. Then you can defer all the rest of the styles to the very, very end of the render process using something like load CSS. The static layout also plays largely into making AMP fast. The fact that AMP knows the dimensions of a thing without needing to load whatever media or component is going into that block, makes it very, very quick for that first render. So you have to provide in AMP the width and height of your blocks. Responsive elements are okay too. There's an attribute that takes that width and height and assumes that it's going to be responsive but keeps the aspect ratio. And so you're locked into that size until a user expresses intent. And then once a user interacts with a thing, then you can allow that component to resize itself or scroll or whatever. And so you can be doing that too. If you're not already passing sizes of your embeds and your images, that's a thing to consider doing because it's really going to speed up that very first impression render that you get. Content prioritization is a thing that in AMP you get for free. Just like above the fold styles are important, so too above the fold media is more important. An image that occurs several scrolls down the page doesn't need to come over the wire before components and media that are going to be interacted with before that. And so again, in AMP you get this for free. AMP takes charge of the whole rendering process and decides when certain media gets downloaded. But if you're not using AMP, you too can use your own component loaders, your own image loaders, your own methods of, instead of lazy loading things when you need them. And that'll And that will improve, again, the rendering process to keep your experience fast. Okay, so DOM mutation batching, this is kind of technical, but I think it's really cool, and AMP does it again. In AMP, you get it for free. The general gist is that every time you access the DOM, the browser is having to apply styles and paint things. And so when we're doing our CSS animations and transitions and effects, we want them to be happening at that silky smooth 60 frames a second. But every time, in the course of our normal JavaScripting, maybe we're reading and writing to the DOM, and we're doing it in no particular order. Maybe we have lots of components on the page, or lots of developers or services doing different stuff, right? And so we're mixing our DOM reads and our DOM writes, and that means we're having multiple paints in every frame, right? And the more paints we have in the frame, an animation frame, the more work the browser has to do, and eventually the browser says, I can't take it anymore, I've given it all she's got. And then, the browser starts decreasing your frame rate, and so you get those janky animations, and we don't want that. It would really be great if we could batch together all of our DOM reads and all of our DOM writes so that we're only painting once per frame. You get that for free in AMP, but if you're not necessarily using AMP, there are other tools like Fast DOM, which is from Paul Irish and some of the other Google guys. Definitely look into Fast DOM. That'll help you manage when you're reading and writing to the DOM to keep everything fast. You can consolidate analytics. This is a really cool aspect of AMP because AMP gives you components for different analytics packages. And the way that works is when you're doing analytics on your page, your Google Analytics snippet is basically just taking some properties of your page and then sending them off to some beacon URL somewhere. And so we really don't need 50 different scripts to be sending analytics to 50 different services. Not that you should have 50 different services, but what AMP does is it consolidates all of that so that you can measure all that stuff once and then report it to several different services in a very efficient way. And if you're not using AMP, you too can kind of build your little analytics switchboard to take care of that if having a bunch of analytics and beacons on a page is a problem that affects you. And lastly, we've got a bunch of pre-connecting and pre-fetching and pre-rendering stuff. AMP automates a lot of this for free for you. Pre-rendering means to render content before a user actually arrives at that content. You get it for free with AMP, but if you're not using AMP, there are other ways to pre-render stuff. I should mention, AMP does this really cool thing where, if it's going to pre-render a page, again, because it sees the HTML and it knows what's on that page and knows how to lay out that page, it knows that it doesn't necessarily need to download every piece of media to re-render that thing in the background. That might be important. And so it'll put placeholders in place of some complex elements, and you can see what that looks like if you want to debug it with this special little hash on the URL. But you too, in your own pages and apps, can be utilizing this same sort of of action. There's the link rel method of allowing the browser to pre-connect and pre-render and pre-fetch some stuff. That does have a downside, of course, privacy, because you might be asking a browser to trigger a view on a page the person hasn't actually viewed. It also can occupy a bunch of CPU and memory because we're doing it in the background, and if data is expensive, then we don't want to be using the user's bandwidth until they have actually interacted with the thing. But we can use the page visibility API to tell whether a page is actually active or whether it's being pre-rendered in a hidden frame. And remember, content prioritization is really important. Pre-render the stuff that a user is most likely to see. So I'm going to wrap up. These are the reasons that AMP is very fast. And there's more of them, and I encourage you to dial up that GitHub page, read the documentation, really get into this stuff. You get all of it for free with AMP, but they're great practices and examples that you can be using in all your stuff. So to wrap up, you're probably asking yourself, okay, this is all cool, but why AMP? Why AMP instead of just paying attention to web performance, right? And that's a great question. And of course, AMP isn't Google's only answer to the web performance issue. You know page speed insights. You know that even is maybe a minor ranking for relevance in some search engines, right? But you're thinking the great Wallaby race of the internet, right? Raise your hand if you've played Wallaby. Oh, I'm so disappointed. In the great Wallaby race of the internet, the hand-tuned site is always going to be faster. If you are doing all of this stuff yourself on your pages, it's gonna win, right? But AMP is always going to come in just a very close second. And the fact that you get all of that for free makes it very compelling. It's a thing that you can use now, and like I showed you, being able to validate and guarantee that content is fast also does have platform benefits because you can build these experiences around them, and it has a business case, right? Because you as a developer are then empowered to show that there is a business bottom line advantage to conforming to this spec. So I hope that I've convinced you that it's a spec that you ought to look into. It's a tool that you ought to add to your tool belt. I hope that I've convinced you that it will empower you as a developer to talk to your product managers to make a good case for web performance, and I hope I've convinced you that even if you are not specifically using the AMP standard, the AMP spec, it is still a great set of best practices for you to explore and learn. Thank you very much for your time. I look forward to talking to you in the break, and again, please let me know if you have any questions or thoughts. I can't wait to meet you.
It's actually on. Yes, it is. Thank you, Michael. That was a great introduction to AMP. I think there's something for everyone in there. It solves a lot of problems. Well, it appears to. So I'm kind of new to the world of dev. I've been a dev for 4 months, and before that, my experiences with CSS were limited to things that I built on my own. So I didn't encounter any of the problems that you'll probably face on a daily basis, which is monolithic apps with 6 years of CSS. So that's what I faced, and suddenly I was like, you know, I don't know if I like front-end dev anymore. But we're all here because we do like CSS. So 6 years of CSS, we've implemented some BEM. So you're probably all familiar with BEM and how it seeks to solve problems of 6 levels deep of classes. It's a messy world. So building on what BEM has sort of tried to solve is a project called CSS Modules, and I just wanted to know how many people were familiar with that project. Yeah, cool. It's a local, well, I guess it started as a local Melbourne project, and we're fortunate enough to have lots of the team in the room, so you don't all have to hassle Josh later. You can talk to other people. But CSS Module sort of takes what BAM has started and carries that through to sort of a different level of implementation. It's a bit of an interloper today because it uses JavaScript, but we're all friends, right? So Josh is going to give us a good overview of the CSS Modules project, and he's going to tell us 6 ways it can help us win, I think. So I'm looking forward to it. Give him a big hand.
Thank you for the introduction. Hi everyone, my name is Josh and I work at X-Team where I make web apps with developers all around the world. And I'm also a CSS Modules team member. And I've been lucky to be able to introduce CSS Modules into some of our projects at X-Team. And that's led me to the experiences that I want to share with you today. This story all began for me last year at Camp JS5. It was a really excellent weekend, and I had a lot of chats with different people about how they were doing CSS. One of these people is in the room today, Mark Douglas, and I kind of watched over his shoulder as he was working on an early version of CSS Modules at the time with Tobias Koppers, the Webpack creator. And I was really impressed with what I saw there. It seemed like it was going to answer a lot of the pain points that I had felt with CSS over the years. Another person who's also here today that I talked to was Glenn Madden, and I saw a lot of the interesting techniques that he was using with CSS, kind of experimenting with a lot of things. And he went on to incorporate a lot of those ideas with CSS modules. So it felt to me like there was a lot of really cool ideas kind of converging around CSS modules, and I wanted to find out more about it. Now, at the same time as this event, I had just started a brand new front-end project with one of our clients, Bugwolf, and I bet you can guess what happened next. You know, you go to a conference, you get your head full of ideas, and then you come back to work, and it's a little bit like that. And it's always smart to exercise a bit of caution when you're trying out a brand new technology on a real project. But at this point, I didn't have to think too hard. I was pretty convinced that it was going to be a great fit for our project. And that was 18 months ago. And I can say that in the last 12 years of doing web development, this has been the most pleasant experience of working with CSS that I've ever had. So I could come here today and tell you all the things that I like about it and why it's just the best and everyone should use it. But it's funny because I've also come across a lot of people who haven't been having such a good time. Thank you. Let's do that.
Hello. A lot of people haven't been having such a good time with CSS modules, and I've seen a lot of discussions online, people getting kind of frustrated about some of the limitations of CSS modules. Now, this is the internet, and so a lot of these frustrations kind of go along the lines of hey, I tried using this new hammer and it really sucks at putting screws in. And we can laugh about that and say, it's not what it's made for, you shouldn't do that. But some people still expect it to work, like Yahoo Answers. Thank you, Yahoo. Stay relevant, buddy. But a lot of the complaints that I saw were actually really valid ones too, and I came to agree that there are a lot of things that are very difficult. Sorry, not a lot of things. Some things are very difficult to do with CSS modules. Other things are just impossible. This is where I got curious. Could it be that my pleasant experience and their frustrating experience were somehow related? Could it be that by restricting our freedom in some areas, CSS modules also opens up new and powerful ways to solve our problems that we didn't have before? So that's what I want to look into today. Now, a lot of people put up their hands before, but I'm sure there are still plenty more who are wondering at this point, what is this CSS modules thing? So I'm going to give you a very quick introduction.
And here's an example of like what it looks like to use. So we've got a CSS file up here and a JavaScript file on the right. There's nothing unusual going on there. But the thing to notice about these two files is that they're both counterparts of the same UI component. We've got CSS to describe the styles and the visual aspects of the component, and we've got JavaScript to describe the structure and the logic of the component. Now the point where CSS Modules kicks in is right here where we import the CSS file into our JavaScript. And when we do that, when we import CSS into JavaScript with CSS Modules, there's two things that happen. First of all, we get a result back from the import. We get a dictionary of class names that we can use to style our DOM elements. And the second thing that happens is when we import a CSS module, all of the CSS content that you see on the left, that's going to get included in the final output bundle that's sent to the browser. So we have everything here needed to render a UI component, and CSS Modules helps to kind of wrap it up into a single encapsulated unit, and we can use this to build up our system, our front end. And that's where the name CSS Modules comes from. Just like how we have a JavaScript module that has a self-contained scope and API based on imports and exports, it's the same thing here, just with CSS. Now, there's much more that I could say about CSS Modules. This was just a very quick introduction, and we'll see some more as we go on. But you know, there's not heaps more to it. One of the things that I love about CSS Modules is that it's pretty conceptually simple. And there's not, you know, once you grasp the basics, it's easy to understand what's going on. Before we do go on, the title of the talk is 6 Ways to Win with CSS Modules, and I'd like to say something about that. Why win? Well, CSS can be a bit of a battle sometimes, can't it? Like, when you start out, it's really easy. You say, make this thing red, and it goes red. It's awesome. It's so easy, it feels great. You get a good result. But then, you know, you go on, your project gets bigger, you add new features, requirements might change from what they were originally, maybe your team grows, things can start to get a little bit hairy and out of control. And, you know, at this point, yes, the house is on fire, but you can still be pretty optimistic that things are going to be okay in the end. We're going to get there. But things can get really out of control. And you can build up so much technical debt and complexity that all you can think about is, like, let's just wipe this out and start fresh. So there's that aspect of winning. We want to avoid all the complexity that's pushing us over this way and stay in that nicer left-hand side where, you know, we're still in control of things and it's feeling good. And that feeling good is, you know, I want to say it's important. Like, it's not the most important thing. It doesn't matter if we feel good about what we're doing, but, well, it does matter. It's important because you can tell the difference in any craft. You can tell the difference in the end product when people have really put their hearts into it. And so having that feeling of winning, of overcoming complexity, it's an important kind of morale boost. It's going to keep us going when things are difficult. And I think you all know this feeling. In fact, I think I can produce that feeling right now. Because nobody would ever waste their time playing solitaire if you didn't get this at the end. That is the power of the feeling of winning. And when we talk about winning, you know, another thing comes to mind, of course. An Urban Dictionary defines winning as a constant state of enjoying life. It does not end, otherwise one was not truly winning to begin with. Hence the suffix ing. Because I'm sure that you've all had that experience of using a shiny new technology, and it's great at first, and then it starts to create more problems than it solves, and then you're stuck with it. See, in those situations, you did win, but you were not winning. And we're going to need that ing if we're going to make something good that lasts and find joy just in the simple act of making it. So I want to show you today how there are 6 ways that CSS modules can help us to achieve that lofty goal. And that it can help us not just at the start of the project when things are easy, but all the way through, from authoring through to debugging and all the way through to refactoring. Now, one of the first problems that I think people come to with CSS modules is coming from that simplicity that I mentioned before, because the flip side of simplicity, of course, is that it might not have the features that you're used to if you're coming from another language. And I can tell you about one time that we ran into this problem in our project. So it was pretty early on, and we were building this nice leaderboard component here. So the leaderboard component is like the overall thing, and then a sub-component. Each of those rows was a sub-component that we called a rank. And we had the code that looked something like that. I was doing a code review with a teammate, so we're sitting down and thinking, okay, we can see there's some duplication going on here. We better fix that. So our first reaction was to rewrite it like this. So we've nested all of the other selectors under that first rank and got rid of the duplication. It's a go-to solution when you're using something like Sass or less, and it helps to sort of keep your code cleaner. But the catch is this code on the right, by default, that's not going to work with CSS modules, just like how it doesn't work with plain CSS. And so at this point, we started to think, okay, maybe we need to run this through Sass first, and then into CSS modules. And that would have worked, but before we even got to that point, we saw that there was another way we could get rid of the duplication. See that? We just deleted those extra dot ranks because we realized we didn't actually need them. And the reason they were there in the first place was just out of habit. We thought that's just how you write CSS. Because it's a really common practice in CSS to namespace your selectors like that, so that they don't get confused between one component and another. But here's the wonderful thing. CSS modules automatically namespaces your classes for you. And it does this by sort of rewriting each class name so that it's guaranteed to be globally unique. In development, we can have like a nice descriptive path to that component, so it's easy to see where it came from. In production, you can reduce that down to a smaller symbol. And so I got excited about this very simple thing way back when we were doing the project, and I still kind of am, because I think if you can improve your code by deleting some of it, while at the same time avoiding adding another tool to your stack, that's kind of winning all over the place. And we don't need more features if we can remove the underlying problem to begin with. So I want to say that's our first way to win CSS today. Don't manually namespace your classes. Let a computer do it for you. They love that stuff. Now, I talked about rewriting class names, and there's a little bit of magic going on there, right, to do that rewriting. And you might have come across a lot of CSS and JS techniques that involve a significant amount of magic, like getting hover states and media queries to work when using inline styles. That's quite a bit of magic here. So what kind of magic do we use with CSS modules? Well, the best way to see that is to compare the source code and what actually appears in the browser. And you'll see that it's pretty much only the names have changed. Everything else is, there's some auto prefix stuff at the top, but everything else is pretty much identical apart from the names. So there's only a teeny little bit of magic to rewrite those class names. And when you're using CSS modules, you're still using actual real CSS all the way through from start to finish. And I would even say that CSS modules is not exactly CSS and JS. It's more like imagine if you've got CSS land up here. JavaScript land is way down here. And you can't get between them because there's this big fiery pit. Well, with CSS modules, they're still two very separate places, but we get this nice bridge. Wow, it's fantastic. It really is. And so that's our second way to win today. CSS modules allows us to write real CSS, but with less hacks and with a nice bridge over to JavaScript land. So there's some nice simplicity about it, and it's real CSS. But you might also ask, why do we need to bring JavaScript into it? This is a CSS conference. We don't do that. Well, why can't we just use plain HTML templates? The long story is you can, but that's something to talk about another time. But I want to show you how CSS modules can make you type more, and that might feel like a problem, but we can explore that. So let's have a look at an example of using just plain HTML templates. It's the same as before, but no JavaScript. If you want to apply one of these classes to the DOM, it's really easy. You just type the name in. You don't have to mess around with importing CSS file into JavaScript and using the dictionary of class names. You just type the name and it's there. And this might seem simple on the surface, but the thing to note about this example is what we don't see. Because these two separate files are still highly dependent on each other. The fact that we're using that string root here only works if there's a corresponding one in the CSS file. We all know that. Same with avatar. We've got a mapping from heading that doesn't actually go anywhere. Maybe somebody changed the CSS but forgot to update the HTML. Who knows? But the point is, there is an API between these two files. It's just not a good one. It's completely ad hoc and unenforced, and you won't get feedback if you've done something necessarily wrong. Let's compare that to our CSS modules example. And I hope you can see that straight away we've got now an explicit mapping between the DOM and the style sheet rather than something just based on arbitrary strings. We're using properties of an object now. And we can take advantage of that in a whole lot of cool ways. For example, you could use flow type or TypeScript to tell you if you've tried to apply a class name that doesn't exist. So that's kind of awesome. And that's our third way to win CSS today, is that CSS modules allows us to have an explicit mapping between CSS and the DOM, and a tangible API that we can do a lot of cool stuff with. Now the next one is a big one. And a lot of people have run into trouble with this. It's that CSS modules will break some familiar patterns. And I've come to kind of really love this one because it's forced me to rethink a lot of my approach to how I write CSS and to learn a lot of new things. So I'll show you an example of a very common pattern in CSS, and then we can talk about why and how we're going to rethink that. So here we've got something called a label, and it's red. Easy, feels good. And then at some point later on, we're redefining the color of a label to be blue whenever it's in the context of a module. Using the cascade like this it's probably like something you learn on day one of how to do CSS, and it's so familiar, and we use it so often, that I think we sometimes forget about the cost involved. Because ask yourself this question: did the author of this code really intend to redefine the meaning of label? Or were there two separate elements both called label? So is there one label that looks different depending on where it's used? Or are there two separate things both called label? Know the answer? Neither do I. Because there's actually no way, purely at the language level, to express that intent one way or the other. Like, the best that we can do is follow a convention or leave a comment. Let's ask another question. what color is a label? It's a pretty simple question. But again, we can't answer that question until we know the entire structure of the DOM, and you also have to tell me which particular label element you're asking about before we can get an answer. So we can use the cascade like this, and it's really easy to get the effect that we want, but it comes at the cost of predictability, of being able to answer these kinds of questions just from looking in one place. Our code has become very, very context dependent. So why is this a pattern? Well, we use it a lot, well, I use it a lot when we're building components that we're going to reuse across the system. So sometimes they have to look slightly different in different places. If we go back to our leaderboard example from before, each one of those rank subcomponents has an avatar. And we know that an avatar, we're going to use that in other places in the front end as well, like in the profile settings that you see up there. But it's a different size up there. So the way that we'd traditionally do this is we'd have our general purpose styles in the avatar component, and then in our leaderboard component, we use a cascade rule to override some of them, the ones that we want to change. And this is the precise point at which we hit a wall when we're using CSS modules. Can't do it. Because do you remember how CSS modules rewrites the class names to be globally unique? Well, what that means is that the leaderboard component can't actually know what the class names of the avatar component are going to be. So you can't target them with a cascade. Some clever people have put some proposals forward to add features to CSS modules that would make this kind of thing possible. And that would be kind of cool. But I was thinking, and even if it were possible, I don't think I would want to use it because of the costs involved that we saw before. And I think we've got a much better way. So the key to figuring this out, I think, is to understand that what we've got here is not just styles. We've actually got some logic in our CSS. It's display logic, right? And we could write that as pseudocode, like if the avatar appears within a leaderboard, then make it smaller. I spoke before about the separation of concerns in a component, how we've got CSS for visual aspects and JavaScript for logic. So we've got display logic here that would make sense to include that in that same grouping, wouldn't it? And when we separate our concerns in that way, we end up with CSS that is much more neutral and predictable and doesn't depend on context. And we've moved the decision of whether an avatar should be big or small to the components API, rather than just giving any other component free rein to reach in and change whatever they want. And there's something else interesting that's happened here in our CSS, because remember we used to have one class avatar that could mean something different depending on where it's used. Now we've got three classes, avatar, big, and small, and their meaning never ever changes, no matter what. In other words, we've made our classes immutable. We can still compose them together to get the effect that we want, but we're never going to change what they're meaning. And think about the effect that this has on your experience debugging. Whenever you see one of those names, you'll know precisely what it means without having to do all that mental gymnastics of figuring out which context are we in right now. So that is our fourth way to win CSS, is that CSS modules helps us to embrace immutability and get all the benefits of that. And it also has some great first-class support for composing those immutable classes together. Now, the next problem that we encounter, a hurdle, is not a hurdle for everyone, but for a lot of people, they'll face this point of saying, oh, I need to use a build tool now, like Browserify or Webpack. Because there is actually no runtime with CSS modules. Everything's happened at build. Now, this is kind of a whole other topic of its own, and I'm not going to dig too deep into that, but there is a pretty strong case for using tools like this. And they've fundamentally changed the way that we think about front-end code. Like, even just a few years ago, many of us were bundling our front-end assets something like this. We'd get all of our JavaScript files and concat them together. and then we got all of our CSS files and concat them together, and then maybe do something with images or SVGs or whatever. But with these modern tools, we have a much more natural way to describe a component-centric front end. So we start with an entry point, and then that has some dependencies on other modules, and then we have our UI components down here, and CSS modules is just a natural extension to that tree. So each one of these UI modules depends on some CSS that it imports. And having everything in the one tree means that we can be a lot more strategic about how we split things up, how we modularize, and it also helps our tooling to make much smarter choices about how to optimize what gets sent to the browser. So that is number 5 way to win. CSS modules allows us to give our JavaScript modules CSS dependencies and have everything in the one dependency tree. Final one for today is fork, aka the fear of removing CSS. Because if you're like me, you've been in plenty of projects where like everybody knows there's this bunch of CSS code that we don't actually need it anymore, but nobody's got the guts to remove it because it's probably going to break stuff. And so it just kind of sits there and accumulates over time. But what happens when all of our CSS is part of a dependency tree? Well, you can imagine when one of those UI components is not imported anymore, it becomes disconnected from the tree, and so the CSS module is not connected anymore either. So at that point, we can just delete the whole thing. I really, really love this, and we've come to this point a few times in our projects now, and it is a wonderful feeling just to delete a big slab of CSS. You should totally try that. That is our final way to win CSS for today. CSS modules helps us to defeat fork by writing our CSS as modules that are really easy to delete. So to wrap up, we've talked about a few of the problems and a few of the hurdles that you're going to come to if you're using CSS modules. But everything is a trade-off. And we often talk about things like, this one is good and that one is better. But I think we should really be talking about what does it cost and what do you get in return. That's the stuff that you need to know to figure out if it's going to be a good trade or not. So we've looked at some of the way that CSS modules gives us value across every stage of our project. When we're authoring, we can just write very simple class names without having to think about a global context, just stuff that makes sense for your module. And they're going to be automatically namespaced, so there'll be no collisions with other parts of the code. When we're debugging, we get the benefits of immutability, of being able to look at a class name and know, yep, I know exactly what that means without having to figure out the context. And having an explicit mapping between the DOM and the style sheet means that it's very, very easy then to trace your way back to the source of an error. And when we're refactoring, we can be strategic about how we split things up into modules and reuse components because everything is part of the same dependency tree. And as soon as a CSS module is disconnected from that tree, you can just delete it without a second thought. So those are my 6 ways to win with CSS modules. And I said at least 6 because there are just so many more that I don't have time to talk about today, but I'm sure that you're going to discover them for yourselves. And please come and chat to me afterwards if you'd like to talk more about that. So wrapping up, huge thank you to all of the CSS Modules team and contributors. There's a lot of them now. And thank you for making this product that has been such a joy to use over the last 18 months for me. Thank you as well to all of the CSS Conf organizers for putting in all this hard work to get us here today. And thank you all for listening.
Okay, thanks so much. Did you come up with fork? Or Thanks for coining that. That's a great word. And I think we have to defeat that indeed. Okay, thanks again. Great talk. Good news again. Lunch has been prepared and is ready for you. I had a peek at the menu and it's mouth-watering. There will be meat options, but also a lot of very healthy and tasty vegan and vegetarian and gluten-free options. If you have any other food requirements, talk to the catering staff. I'm sure we can make you happy. Also, pro tip for the coffee addicts. If you want filter coffee, you can skip the line. It's delicious. Do it. I'll see you back here at 2:10 for the second half of the day. Enjoy lunch.
Okay. Hello. How is everyone? Yeah? Tommy's good? Everyone else good? A few stragglers coming in? All right, so lunch was good? Everyone's happy? So I had a slightly clunky introduction this morning. I've got a bit of a cold, actually. I'm nearly over it, so that's good. And I'm properly medicated, so hopefully this will be a bit better. I've got an absolute pleasure to introduce you to Nadie Bremer. She's a data visualization person. I've just started a new job in a data viz role myself, so I'm really excited for this work. If you haven't seen her work, you should. It's absolutely amazing. And I have no doubt that you'll be highly impressed as I was. You have a previous role as an astronomer, correct? And I think you'll see the influence of that and science in a lot of her work. It can only really be described as art with data, I think. And I think you'll see what I mean there. She just makes these amazingly creative works. So yeah, if you haven't seen it, I think you're in for a treat. Could you all make her feel welcome?
Hello, everybody. Well, I thought I'd come one day early so that I would go over the jet lag yesterday and then be awake today, but actually it hit me quite hard this morning. So if I stare off at some point, you'll know why, because I had a 24-hour flight. So anyway, imagine that you spend your days looking at the stars and seeing these fascinating shapes. Well, I started my career working with the infinity of space and handling the enormous amount of data that it can produce. But although I graduated as an astronomer, I switched to a career as a data scientist. But I guess I couldn't say goodbye to the visually focused astronomer inside of me because I found myself loving the visualization of the data even more than the analysis itself. So I switched gears again, and I'm now a down-to-earth data visualization designer working for Agen in Amsterdam, although I actually resigned last week because I'm going to go freelance. Whereas right now, still at night, I work on personal projects, experiments, and write tutorials for my website, Visual Cinnamon. And I found that in data visualization, I tend to be a perfectionist. I love spending hours and hours on some small detail to make it exactly as I have in mind. And being born and raised in Holland, I always willfully hope that maybe my craving for perfectionism stems from the same genes as those of the Dutch master painters of old, who managed to put such a dedication to detail into their artworks. You know, it's a small country. So, even though painting and data visualization isn't exactly the same thing, I do always start my visuals on plain paper. And once I have a mental image of how something should look, the computer had damn well be able to create some semblance of that on the screen for me. However, usually what I have in mind isn't quite the default setting or what all of the examples are using. And it forces me to try and think outside of the box from time to time to try and recreate my concept. But you'd be surprised by the results if you try to experiment with the norm, use things in an unconventional manner, or get inspiration or elements from different fields of design to create a more effective or fun visualization. So, almost ready to take off, go beyond the shapes, but first let me explain how SVGs fit into the world of D3, which is a JavaScript library that has become the standard for online data visualization and is what I'm using for all of the examples to come. So once you start building with D3, you quickly figure out that its basic building blocks, its shapes, are SVGs. And by combining these circles and rectangles and lines and paths, you can create some awesome visualizations. And I'd like to take you along on my journey on how I started using SVGs beyond their mere shapes. Well, my first step beyond the shapes came when I was trying to create a color legend. And I was looking for a way that goes smoothly through all of the colors that I was using. And that's how I got into gradients. See, the point was that it wasn't really necessary to read off the exact value that each color represented. It was more about seeing trends and getting an overall sense of the numbers, like in a heat map, for example. So this one shows the number of traffic accidents that occurred during 1 year and aggregated by day of the week on the vertical and hour of the day on the horizontal. And the darker color, the more accidents that occurred in that combination. So no surprise that
the morning rush hour, and especially the evening rush hour, have the most accidents. But it's really about seeing these kinds of trends. It doesn't really matter if it was 1,470 or 1,520 accidents. And the legend below is what I mean with having something that goes smoothly through all of my colors. And it's nothing more than a simple SVG rectangle filled with a gradient. And because I'm going to show you a few more gradient examples, I'll first explain how you can create one based in the code of D3. And yes, I know this is a CSS conference, but you'll see some JavaScript here, which is going to do strange things and imply CSS styles and do something to SVGs. And some of the things I'll show you could be done easier with just plain CSS, but I wanted to show you how that would work in D3's code. Because data visualization is based on data, so things are dynamic, so styles have to be dynamic. And that's why I also need JavaScript from time to time. But anyway, there actually exists a linear gradient element, and you nest that within a defs element. And defs is short for definitions, and it holds special things such as gradients and filters. It's very important that you give your gradient a unique ID so that you can reference it again later on once you set the fill style of your element. And now we have to define the direction along which a gradient should run across your shape. And you do that in a way that's very similar to creating an SVG line with X and Y. So x1, y1 defines a starting point, and then x2, y2 defines an endpoint, which is sort of like a directional arrow. You can supply these values in both percentages and exact pixel locations, but usually percentages is way easier. And by playing around with these values, you can create a gradient along any angle that you might like. But what I'm showing here isn't quite true, because in reality, it's really the bounding box that defines where the start and end point lies. So a 0% starting point really lies outside of the visible shape. And that means that once you see the gradient coming into the shape, it's actually already turned slightly more purple. And maybe you don't want that, and that's fine. You don't have to start at 0 or end at 100%. You can start wherever you want, and then the region outside of that arrow will be filled in with whatever color was present at the outskirts of your gradient. But we're just going to use a plain horizontal gradient. So after setting the direction, all that's left to do is supply it with some color information. And for this, the stop element exists. And you supply the stop element with a stop color and an offset, which is the location along that directional arrow where that color should be pure. So here I've appended a light blue color all the way at the start at 0%, and I need at least one more color for a gradient, so I'm going to append a dark blue color at 100%. And now the gradient is done, it's ready to be used. So I select my element, my rectangle, and I set its fill style by referencing that unique ID. So that might become tedious appending these stops if you have many colors in your gradient, but then we can use D3's data step. So let's go back to that horizontal gradient right after setting its direction, and this time I'm going to supply the gradient with a data set that contains information about the offset and colors that I want to use, and let D3 append a stop for each of these. After that, it takes 2 more lines to set the right offset and stop color by referencing the data that is now attached to the gradient. And finally, you get that result. So here is another example that is, in essence, a heat map and can thus be combined with a smooth legend. It's the visual output of a machine learning technique used to cluster data called self-organizing maps. And it's what started my love for hexagons. And I wish I could say I was using the color palette that's visible right now, but I started using this technique before I really got into data visualization. And I do come from a science background, so my go-to color palette was a rainbow, of course, which I now know is not a good choice for continuous data. It still looks nice, though. Well, staying in the rainbow mood just a bit longer, here's one of my favorite temperature visualizations, if you can see it. So what you see here is a weather radial I recreated for New York for a year of data in 2015. And each of these bars is 1 day, and it goes from the minimum to the maximum temperature measured on that day, and it's color-coded according to the average temperature. And here it's really, again, about seeing trends. So when was it really hot, or when was it really cold? Well, being an astronomer, I, of course, wanted to make a visualization about exoplanets, which are planets that lie outside of our solar system. And my setup was to do a bit of data storytelling to explain how weird and amazing these planets really are. But to make these circles all rotating around one generic star a bit more than, well, flat circles, I turned them into tiny spheres by using a radial gradient. And I also made each of the gradients slightly different because I made them depend on the data of the planets. And creating database gradients is also straightforward with D3 because we can use the data step like we did before in the legends case. However, now I immediately append my data set of planets to the depth element so that D3 will create multiple radial gradients, one for each planet. Still very important that you give each of your gradients some unique ID. And then afterwards, we can use the data that is now connected to each of the gradients to set something like the base color of a planet. And then I can make it lighter on the inside and darker on the outside, move that center location a bit, increase that directional arrow, and now we have something that sort of mimics a 3D sphere. And if you were to then look in the DevTools, you'd find that you have many radial gradients, one for each of your planets, and all of the colors for each gradient would be slightly different. Finally, again, we select all of our planets, and we connect them to the right gradient. Well, instead of showing you a visualization about exoplanets, about which many have been made actually already, I thought I'd show you what I think is one of the most important plots in astronomy, a Hertzsprung-Russell diagram. And here, the circles are no longer planets, they're actually stars. I've chosen some of our nearest stars. And on the vertical scale, we have luminosity going up, and on the horizontal scale, we have temperature. But note actually that the hotter blue stars are on the left, and the cooler red stars are on the right. And that's due to historical reasons. So our sun is somewhere over there. And these planets in the upper portion, like Betelgeuse and Antares, they are indeed bigger than our sun, but in reality, the scaling isn't quite right, because this is the true size difference. Yes, space is big. But you know, this doesn't really make for a very readable plot. So that's why this downscaling is amplified. But also, stars are, of course, the things that shine. They aren't actually shined upon. So by tweaking that radial gradient a bit, I could try to make them look a bit more like the glowing orbs that they really are. So another reason why I really like this plot is that there's very little visual encoding done. I mean, stars, they're actually round, and they are visible to us in these colors. So it's almost as if you're plotting the things themselves. And I personally don't know of a better subject to use for scatter plots than stars and maybe planets, but I might be biased. Well, besides using data to set the color of a gradient, you can use it to set any attribute, really, such as the direction along which a gradient should run. So after watching the second Avengers movie, I was interested to know how each of these Avengers were connected. How often had two of them appeared in the same movie together? And I thought that D3's chord layout, which is a chart type, would lend itself nicely for this dataset. So here we have the result, where the thicker a chord, which are these inner lines, the more movies the two Avengers have appeared in together. However, by default, a chord is given one color. But that doesn't really work so well with this dataset because the connections are symmetrical. Since if Thor appeared in a movie together with Hawkeye, well, then the reverse is true as well. So I wanted to do something else. I could make them all gray, but that felt a bit boring. So instead, I wanted to fill them with a gradient, running from the color of one Avenger to the other. Well, to pull that off, let's focus on Black Widow. So for these 5 chords that you can't see, actually, well, that's fun. Let's see how it goes on. It's actually over there, Black Widow, 5 chords. You want to create 5 linear gradients, that run across these directional arrows and that have a start color and end color as given by the small circles. So something that looks like this, but then inside the chords that you can't really see. Well, one of the many nice things about D3 is that it helps you prepare your data for whatever chart type that you want to use. So you supply your data, and D3's functions will transform that into widths and angles and paths, things that are needed to draw SVG shapes. And for this particular layout, D3 returns an array that contains all the information I need to draw these inner chords, and it's usually named chord.chords. So as in the planets case, I immediately append my chords dataset to the defs so that D3 will create one linear gradient for each of my chords. And one thing I wanted to point out is that in this case, it's actually easier to not use the bounding box of each chord to define the direction, but instead use the coordinate system that I've put in place with its origin right in the center of the circle. You can do that by setting gradient units to users based on use. But the reason is that in this rare case, it's actually easier to find the exact pixel locations of these two colored circles by using the variables available in the chords dataset together with some sines and cosines. So after setting these directions based on the variables, we need to fill it with two color stubs. One at the start, that's color-coded according to the Avenger at the start of the chord, and then one at 100% that's color-coded according to the Avenger at the other end. And then with those changes, we get the following result, where each of the chords is now a representation of both the Avengers that it links. But you don't actually have to use gradients as something that runs smoothly from one color to another. They can be very handy for abrupt color changes as well. So many very fascinating analyses of baby names have been done in the past, such as the most trendy or poison or unisex name. But I was interested in something much more simple. I just wanted to know how had the top baby names risen and fallen from fame over the past years. And I was surprised to find out that the data available actually goes back to 1880. However, a typical screen isn't wide enough to do justice to 135 years of volatile change. So instead, I applied the focus and context technique, in which we have a small chart below that shows you all of your data, and then from that you can select a window that is then visible in more detail above. And you can move the window, make it bigger and smaller. But to make that connection between this bigger chart and the small window more intuitive, I wanted to color both of them the same, but only within the selected window, and then gray outside for this smaller chart below. However, you can only stroke a line with one color. And I didn't want to have to cut these lines up, so before, within, and then after the chosen window, and then change that dynamically when somebody moves the window. So instead, I went for a gradient approach. So again, there's gray on the left side. I appended a gray stop at 40%, and then right after that, I appended a colored stop at exactly the same percentage, 40%. And then you get a really abrupt color change. Well, I do the same at some higher percentage, but in reverse order. So first a color, and then gray, and then we get another very abrupt color change. So if I now pick a rectangle that probably, yes, you can only see the center of, which has gray on the sides. It would seem as if you have 3 rectangles, but really it's only one with a gradient. And then by changing these 2 percentages, when somebody moves the window and some form of update function is called, the gradient really seems to move right along with the choices that the user makes. But it can also be very handy for showing categories. So here we have the trend of the mean body mass index over the past 40 years for a whole bunch of countries. And although not so abrupt in real life, according to health standards, you become overweight when your BMI is above 25 and obese when it's above 30. And usually what people do is that they sort of place rectangles behind these categories to make that more obvious. But I wanted to have something that was a little bit more subtle. So instead, I filled the lines with a gradient. And you can still see very well where that change occurs from okay to overweight. And even when you change your data from men to women, well, the lines, they just smoothly go over the gradient, so you don't have to make any color changes. Well, I was also very pleasantly surprised when I found out that gradients can actually be animated. And during a fun project at my previous employer, Deloitte, we had access to a data set that contained information about what education people had done and then what occupation they ended up doing. And we wanted to visualize these results from education to occupation. And I could have used a Sankey diagram, which is very good at showing flows. But the visual was going to be used in the media, and I was looking to create something a bit more eye-catching. And I have a love for circular things, so instead I went back to the chord diagram, and with some tweaking and hacking and changing, turned it into something resembling more of a circular Sankey diagram. But I then wrote a tutorial on how to recreate this and shared that online, and some people started calling it the bad plot, which I thought was way more catchy than circular Sankey diagram. So, the bad plot. But anyway, here is the end result, where you cannot see the chords. There are great chords in there. Going from one end to another, and to visualize this education to occupation flow, I actually filled that with a linear gradient, which I can see on my screen right now. Oh, here you can sort of see it. To make that flow a bit more intuitively clear that people are going from left to right. Well, animating a gradient also gave me an excuse to put one of the most famous data visualizations there is in my presentation. And here we have Menard's map from 1896 about the enormous losses suffered by Napoleon's army in his march to and from Moscow in 1812. And what you see here is the movement of the troops across the land, past villages and rivers, towards Moscow in brown and back again in black. And the thickness of a line represents the number of troops that was still alive at that point. And then we have a line chart below that highlights the devastatingly low temperatures that the troops had to face on their march back. And what I did was, I remembered that first when I saw this chart, I wasn't quite sure how to read that. So I added a slight animated gradient to make it a bit more clear that brown is towards Moscow and black is back again. And when I see this chart, I'm always so sad to see that out of the 422,000 men, so almost 500,000 men that started on this campaign, only 10,000 made it back alive. While leaving SVG gradients behind, we're finally entering the domain of SVG filters. But to be honest, we're also sort of leaving the realm of effectiveness in the visual behind a bit, and going more into having or creating a bit of fun and magic in your visual. So creating a filter starts out very similar to a gradient. This time we append a filter element to the depths, and it's still important to give it some unique ID. And afterwards comes the magic part, where a specific combination of filters can create an effect that you might have never expected. However, luckily, usually you can just copy and paste the same piece of code from visual to visual. You don't really have to make any changes, maybe some numbers here and there. And finally, we select our element and set its filter style by referencing that unique ID. So the first one is rather subtle, but it can have a nice, interesting effect in the right circumstances. Well, some people love radar charts and other people hate them. I'm personally not part of the latter group, so a few months ago, I made a redesign of a radar chart in D3. But although I was fine with it the way it looks now, I remember coming across the code for some from drop shadow or text shadow, and I thought, well, maybe that might make this look a bit more engaging. And I'll show you the glow, it's very subtle. That was it. And it really depends on taste whether you think this is better or not. But what happens is fairly simple. Say that you want to apply the filter to a circle, then it creates a blurred version of that circle and merges the original one back on top of it to give the appearance of a glow. And you can apply this to SVG rectangles and pods and circles, doesn't matter. And another occasion where I found that this had an interesting effect was when I was playing around with spirographs, which I used to love as a kid. And with a bit of glow, it just made it look a bit more neon and then lifted it off the page a bit. So another filter that has an interesting and subtle effect has to do with motion blur. So the faster and closer to us things move, the more blurred they appear. And with the right filter, we can recreate this effect on the screen as well. These circles, for example, the faster they move, the more blurred I make them to give the feeling of fast movement. And I first saw this effect when I saw images being blurred in an image gallery, and I thought, well, data visualization often shows movement, so I wanted to see what I could do with that. Well, this filter is even more simple than the previous one, because you really only do a blur on an element in one direction, X or Y. So now these circles are moving without a blur, and with a bit of an exaggerated blur, you get this effect. So if I take away the blur and put it back in, and I don't know, it's really subtle, but I feel like the second one just makes it look a bit more real. Well, I thought that a data visualization about the top running speeds of some animals and the fastest human would be interesting. So these circles are going to move outward. The faster they move outward, the more blurred I make them. But you couldn't really consciously see that. It's more subconsciously. So let me pull them back in and show you just the blur that was occurring. So the cheetah is the fastest, so it gets the most blur. And then I calculate how much less the blur of the other animals and Usain should be in comparison to the cheetah. And just as a note, if you want, you can apply filters also to images that you've appended to your SVG. So if I move these outward, they get blurred as well. Well, time for my favorite filter, the GUI effect. And I first saw this one when I saw a really nice demo for a loading button. And during the Deloitte Ladies Open, which is a golf tournament, visitors could do a small golf clinic, and then we'd visualize the results. And to show how far the ball had gotten, I could just let the data points appear on the screen like this. But yeah, that felt a bit boring. So instead, I tried to mimic the golf swing by letting the circles fly out from 0. And you know, that felt better, but I wasn't feeling it yet. And then I remembered that GUI effect. And with that small change, the ball now seems to be ejected from the start, as if it is trying to acknowledge the effort made by the participant. And it didn't make the visual any more true or false, but I did find it a lot more fun to watch. So I'm not going to even try and explain how this filter works, because I only understand about half of the steps. But besides this very nice GUI effect, it can also do really nice color blending as a bonus. Again, thinking about data visualizations, maybe you could have, if you want to plot circles on a map, you can let them fly out from some central point to their final location. Or instead, if you want to group them back on a country level, you can, once they sort of merge on a country, they sort of group into representing one country instead of all of these separate circles. And this reminded me of another fun example created by Mike Bostock, who is the creator of D3, which is already fun. It finally works. So yeah, some sort of collision detection. But I think with a touch of goo, it becomes even more fun. Yeah, the most fun is if you can keep one away from. Anyway. So time for the final example. And this one has to do with those amazing color blending techniques where two colors overlapping each other can create an entirely different color. I first tried to recreate this effect using SVG filters until I found out that it can be done with just 2 lines of CSS. But even though this isn't done with filters anymore, the effects are visible on SVG, so that's why I keep it as my final example. So these are my 2 favorite blend modes, multiply and screen. And for those not yet familiar, you can create that effect by setting the mixed blend mode to either multiply and screen. But it's also very important that you group your circles and isolate that group. Otherwise, you might end up seeing absolutely nothing on your screen, no error messages in the console, and you can't figure out what the heck you're doing wrong. But anyway, I tend to use this when I have cases of minor overlap. So here we have a very busy line chart showing the average daily temperature in 2015 for 8 cities. But why should the greenish line of Amsterdam always lie on top just because it was plotted later? They're all equally important. And I could use opacities. But for one, I don't want the line of Amsterdam to be any less visible when it's not overlapping. And even with opacities, the Amsterdam line really still lies on top. So instead, I apply a multiply blend instead. And besides having sort of an interesting touch to it, it also, right now, at the point where things cross, you really can't see which line lies on top. There is a blend going on. So not one city is more important than the other. You can also do this for circles, but only if they're not completely overlapping. So here we have a completely random slope graph of animals where we have the same issues. For example, in the top left, we have a purple giraffe overplotting a red deer, but all the animals are equally important, so again, I apply a multiply blend. But maybe this effect really shines best when it's used in some sort of data art or generative art kind of approach. So for my final example, I'll show you something that I can look at indefinitely. And the color blending really makes for a more interesting result, because if I turn it off, you get this, and I'd say that definitely has less magic. Well, I hope that some of these examples might help you someday to create an even more effective or fun visualization. I hope even more that I've inspired you to always go beyond the norm, so that you have to make as few concessions to the computer as possible to try and recreate the image that you have in your mind. And finally, I hope that you'll go beyond the shapes. So you can find way more examples and all of the underlying code to everything that you just saw in the 10 tutorials that I wrote on them on my blog. And finally, thank you very much for your attention.
Hello, CSS Conf. So you may not know this, but running a conference is really a complicated set of spreadsheets. Spreadsheets and spreadsheets and spreadsheets. And if we learned anything in the previous talk, data is important, but communicating data well is more important. No one wants to stare at spreadsheets, but they want to stare at motion blurs and graphs and directionality. And that leads somewhat into our next talk, in that Barak, coming all the way from London, does a lot of really great talks and work on multimedia and multimedia and interactivity in CSS and JavaScript. So what he's talking about today, is something new called Houdini. And some of you may work in something like SAS or less, and anyone who works in something that compiles down to CSS will know that the limitation is always CSS. And Houdini is going to open up a whole new world of more powerful CSS, which will make more powerful tools like less and SAS do greater things. So we have Barak away from London to talk about what will be available in the future of CSS via a project called Houdini. And the laptop is not ready, so I'm going to be entertain you a bit more. No, I'm not. So we'll get Barak up on stage.
Maybe the window ran away. Let's see. Chrome. Where did it go? Yeah, I'm just. Oh, here we go. I'll just plug this out for a second. Yeah, this one should be. How do you choose which screen goes out?
Just drag that across and drag it along.
Yeah, that'll work.
That'll be easier.
Which side? Here we go. Okay. Okay. So, hello everyone. I'm Barak. Today we'll be talking about the Houdini Spec, and we'll get exactly to what it is. I'll start with the mandatory short introduction. I'm a web developer based in London currently, even though after being here for a few days I'm starting to reconsider my life decisions. But I've been doing web and front-end development, web development and design for a long time, back when Markey and Blink were still working and not deprecated. And I've seen the web transition through different phases, JavaScript and CSS through CSS 1 and 2 and 3, and JavaScript ES 5 and 6 and now 7. And our tools and our languages that we're using evolve all the time. And what I want to talk to you about today is how can we deal with this ever-changing, probably the most dynamic environment in programming and in development today. So really what we're talking about is magic. It's the magic behind CSS, how to understand it, and how we can make our own magic. But before that, let's talk about the parts of CSS that are not as magical. There's a term in Japanese called chindogu. And chindogu is the art and tradition of building over-engineered, sometimes seemingly useless inventions to solve everyday problems. So we can see some really great examples. And they are, at the end of the day, these are useful, but they're just seemingly over-engineered. And how does that relate to web development? Where can we see over-engineering in our daily life? Well, let's talk about rounded corners. Rounded corners, up until a few years ago, before border radius became ubiquitous, the wet dream of all web developers, the entire web went rounded. With Web 2.0 and Apple's inspired design, we all wanted border radius on our divs, and we used it everywhere. But the problem was that the adoption of border radius in browsers was not clear-cut. It was not available across the web immediately. So we were building our websites on our powerful MacBooks and fancy Canary Chromes and latest versions of everything. And the latest and greatest of CSS was working perfectly. But when you open a website on IE 6 or 7 or 8, you'd be horrified. And all the work that you've put into your amazing website, and it just looks like crap, doesn't work, the layout breaks, it's a disaster. So we started becoming inventive, and we invented our own border radius. And let me just find my mouse. Here we go. We invented our own border radius. And if any of you recognize this, we started using images to render them to the color of our divs, and we created our own border radius. I think that qualifies to the definition of over-engineering. And why do we have to deal with these problems? Why do we have to render images to pretend that we have border radius to make sure that they're visible to everyone? And the answer is the process of CSS standards. How do new features of CSS end up on the web, in the browsers, available to everyone? Well, we start by proposing a feature. Each part of CSS starts as a feature proposal. And we can say, I think border radius is a great idea, and we should have it. Well, you go on to write a spec to detail an API, to say why it's beneficial, to give examples, to write a mock implementation. And then the vendors, Chrome, Firefox, and Safari, they go on to implement that spec, the CSS spec. And then people update their browsers, and they get better and better adoption of new features, and only then can we use these features. The problem is that between vendor implementation and browser adoption lies a chasm where CSS specs go to die, and features can spend years there. If you look at the implementation of Flexbox, it was several years, and we're still battling that today, even though adoption is pretty good, before at least majority of users, above 70 or 80%, had browsers supporting Flexbox. And rounded corners is sort of a nice to have, but if your layout is dependent on support for Flexbox and it's not there, everything is going to get messed up. And I'm sure you're familiar with this can I use charts that are often very depressing, telling you that only your version of Chrome supports this one thing that you are hoping to use everywhere in your project. And it could be really disastrous to a web project if it's open on older browsers and everything's completely broken. So what usually happens is that there's feature proposals. Someone comes up with some kind of workaround, and we just go with that workaround because we're too afraid to just go with the fully fledged CSS implementation. And then we use it. The problem is that these implementations are often, as we said, over-engineered. Using images for border radius anywhere on your website is not feasible. It's a lot of images, it's a lot of weight, it's a lot of work. Implementing Flexbox in JavaScript can become very slow and very sluggish and can bring the performance of your application down. So what I'm here to tell you now is that you can make your own magic. You can, with a new set of tools that will be available to us hopefully in the near future, make your own CSS, create your own implementations, and not have to rely on polyfills or workaround. And when I first saw this, it was mind-blowing to me. The kind of stuff that we'll be talking about today, and the APIs that Houdini, that is the code name for the task force, and this collection of APIs makes possible. So yeah, Houdini is the CSS spec that will give you web magical powers. And we'll see exactly what that means. But to be able to understand what Houdini does, we need to first understand how the web works and how CSS works, and get into the details that we usually avoid, and we usually don't dig that deep. We know how to use CSS, we know quirks mode, we know behavior in different browsers, but not necessarily the engine itself and what the browser does when you give it HTML and a style sheet. Well, what happens is a process with 4 stages. You start with the style sheets with what's called the CSS object model, which is how do we map a tree similar to a DOM of all of the different properties and classes and elements. We propagate through the cascade, and we assign different properties of different importance to particular targets in our DOM. We run through a layout phase, which is where we organize all of the elements in the page in their final structure, be it block elements or inline elements, different kinds of displays. We go through a paint phase where we actually render these components to a visual, to different layers, and we go through composition. And composition will place those layers on the screen, and we'll end up with a fully rendered web page. So we'll go through a few examples of the Houdini Spec APIs and explain how they give you better access into the internals of CSS. And the first one is the CSS Parser API. And it might not seem very exciting at first, but let's see what it looks like. So you can see that that's a bit small, so I'm going to zoom that in a bit. You can't really see at the back, right? No? Okay. Oop. What did I just do? Command P, Alt P. Ooh, we went quite a long way back. Yeah, more GIFs. Here we go. Okay. So, and we'll carefully zoom this back. Okay. So the first thing that you can see that we do is parse a style sheet. We have an API in the browser, in JavaScript, to get a CSS rule and get back the properties and the values. And we can do the same with a style sheet. We can fetch a style sheet and pass it to a CSS parser, which will be a function available to us in JavaScript. And we can parse the values of that style sheet. And I know that doesn't look very exciting, but the purpose of this API is not just to be able to parse style sheets, is to be able to create our own, really create our own additions to CSS itself. I'm going to zoom that back in a bit, and we can see what you'll be able to do is implement your own constructs, something like custom functions, and we'll see what kind of possibilities that opens, or custom at rules in the same way that we use typefaces or media queries. And even if you've used the new feature for image sizes to have multiple sizes of images on one tag, CSS-like attribute values. And I know that seems very technical, but think about what could you possibly do with your own custom CSS functions and CSS at rules. And when I think about what's exciting to me and what I'd like to try when this API becomes available, I think of, for example, chroma key. Imagine you could have something like Hollywood green screens, and you could drop the background of an image and make it transparent within CSS. You could implement the rendering engine for that function and make it available within CSS. It's not Sass or less or any sort of JavaScript polyfill. You're extending the CSS engine itself. For example, you could select a frame from a GIF, which is something I'd love to try. You could create a selection of more interesting image filters. If we're looking at rules, you could implement your own inheritance for classes and properties in the same way that Sass-less or any CSS precompiler does it. We could create our own definitions in the same way that typeface is used to make fonts available globally in a document. Maybe we can create something like a color palette available widely in a document. So you extend CSS itself. This is loaded from a regular style sheet into the browser, and you have to, you'll be able to define the behavior of the process, the parsing of each of the rules on its own. Oh, here we go. And to show you perhaps some of the more power of when these APIs come together, and it's all about the different APIs and the I guess, the wide range of possibilities that they make available when they're combined, I want to look into the Properties and Values API. Has anyone experimented with custom properties or CSS variables? A few hands. So custom properties or CSS variables look something like this. They allow you to define a custom-looking attribute and assign a value to it. Now, currently, when you do this, when you assign palette root in the root level of, or any level of your document, it becomes a variable that is available to you to use in other properties. So you can define a color and reuse it everywhere. But it's used as a string. So it uses orange as a string. It doesn't know what orange is. It doesn't know what orange does. And we just hope that when you feed orange into color maybe, or background color, CSS would know what to do with this. Well, the new Properties API will give you an interface to define more robust properties. For this example, something like palette root, we can tell the CSS engine that palette root is a color, of a type color, and we'll see later on why it's important that CSS knows the type of our values, that it inherits from its parents, that it has a default value. Now, what that means in terms of our development is that we can set this property once, but the CSS engine is aware of the value. So one advantage, for example, is that we'll be able to animate these values, because if the CSS engine is aware of a value being a color, if we transition into another color, it is able to create the curve of transition between these two things. It's not just the separate unknown values that are either strings or numbers. These are values with a meaning. And if we're talking about values with meaning, the third upcoming API is the typed CSS object model. And the typed CSS object model is extended on top of the regular CSS object model, and we'll see what that means to solve this problem. And you might have been familiar with it. And that is trying to get a value out of CSS into JavaScript. Let's say I want to know what is the width of an element. Well, currently I have to get the style sheet for that element, get the property. It'll be something like 100 pixels. It'll be a string. I'll have to split that string, drop the pixel, turn it into a number, only to get the width. And if I want to set the width back in, let's say it's calculated, I have to generate a string again, pass it into the CSS engine, which will parse it back into a number, and all this loop was just because our interface is strings, which is a very poor interface. So not only is this annoying, if you do it a lot, if you do it every time you scroll, every time the browser window changes, every time you hover over an element, it really drops in performance. If you had the experience of trying to create dynamically sized elements in reaction to mouse hovers or scroll, something like the Twitter header, which we'll see another implementation of later on, it becomes very, very slow. So instead, what Houdini proposes is a typed CSS object model, meaning that values have a type. They are numbers, they are lengths, they are transitions, they are time, they are degrees, but they have a meaning and they have more context. So, for example, if we want to set the width of an element, we initialize a new CSS length value, and it takes a number and it takes a unit, and then we can set it back to the element, meaning that we operate in a more rich and informed context. We know that we operate in a width with unit, and in pixels that we're dealing with widths or lengths in this case. And what that means is that we can create more elaborate types or more elaborate values with less overhead. For example, the previous example of a calculation with two different units just becomes a new CSS length value with a percent and a pixel value. And these are automatically comprised into a calculation, meaning we don't have to do any more string manipulation or concatenating or splitting, all that kind of stuff. And it's a much better API. And because we are aware of the type of the value, because we know it's a length, we can operate on it. We can do things like addition or division in the case of lengths. In case of a transform, it's really interesting because the transform string itself, the matrix of transformations, if it's a rotation or a translation or a skew or a spin, it becomes very lengthy. And processing that with a bunch of regular expressions or splits in JavaScript can become a very lengthy process. In this case, we have a very strict interface. We create a transform, for example, and we add transformations to it. We can add a rotation, and it has a type of angle. It's a lot easier to understand what's going on. It's a much more robust interface to describe our dynamic styles. And we'll see that the typed CSS object model really empowers a lot of the different new features of Houdini. So now we're looking into more of, these were all APIs that are available in the DOM or in the main thread or in our main processing thread in JavaScript, meaning that we can apply styles, we can read values, we can add some more features to CSS. And I want to look through, like we talked before, how do we polyfill CSS? How do we extend it? How do we compensate for the lack of features in some browsers? And really, the Layout API touches upon this first. So the Layout API allows you to create your own custom layouts. And it might not sound exciting because we can do it with things like Masonry today, or we can just do it in JavaScript, but it provides you with an interface that will be separate to the main thread, and it will work in sort of a worker. We'll talk about worklets in a bit, and it will allow you to define high-performance scripts that will run to generate the layout of your pages, and you can use them straight from CSS. So you can define a layout that compensates for the lack of flexbox or grid or columns or whatever it is. You can load it into, you can load it along with your application and use CSS normally, and these layouts will be available to you. So let's look at an example. But before we look at a layout, I just want to talk a bit about the way layouts are defined in CSS. We operate with boxes and fragments, meaning that even if we have a single line and it's within a single div, there are a few different chunks. And we can use it with, for example, pseudo-selectors of first letter or first word, or if we have a few different spans within a div. You can see in here we have overline, underline, and italic, and they are separate elements. They are all different fragments within one box, within the context of the new structure of CSS. So let's say that we want to create a simple layout that will order elements as blocks, one after another. Well, what we're given is an API where we define a class, and this is done in JavaScript, but the end result, the display layout, is available through CSS. So we'll just run briefly over what the code looks like, and we'll talk about the benefits later. We define a new class, we define a layout, and that layout is being called in the layout stage of CSS. So right after we get all of the selectors, we go through the cascade, and we want to start placing elements around the document. So we get the properties of the elements, we get their width and their height, and this function basically runs through each of the elements and places them in coordinates inside a container. Once it does that, it returns all of the values. I'm not going to run through the particulars of the code because it matters less. What matters is that we get the unsorted or unplaced list of fragments or elements within a container, and we can place them within a bounding box. We know that, let's say, a particular box is 100 pixels, and the next one is, each one of the spans is 100 pixels. We can draw them one after another. We can draw them next to each other. We have complete control over placements of elements. And this entire class is exported and registered as a display. But what that means is that you can later use it in CSS through the layout function, meaning that you can polyfill flexbox, you can create your own layouts. The reference implementation implements Masonry, if you're familiar with Masonry layout library, much like the Windows blocks, the Windows 10 blocks within CSS. So you can just use these displays in CSS, and we'll see later on where this code is actually executed to ensure that you don't have a performance hit or a performance drop to be able to use custom layouts. Another interesting example is the Paint API. The Paint API gives you control over backgrounds or any kind of visuals that you can draw in the DOM. And what it looks like, again, it's another class that is exported to make available in CSS. So we register a new painter. In this example, let's say a circle, and we get the input of an element, and we want to draw a circle in the middle of it. So much like a canvas interface, we get a subset of really canvas to be able to draw whatever we want within the element. So if we ask for the properties, let's say circle color, we ask for a custom property or a variable from CSS, so we're able to interface between different APIs. And then we get the dimensions of a particular element, and we can draw a circle in the middle. Now, I know this looks like canvas, but this is the actual drawing of CSS layers. So we can draw on elements. It's not a canvas container. the way that it looks after you register a circle isn't just in CSS. You can say that the background image is a paint. You paint a circle, and you will have a circle in the back, and it will be in the sort of shadow DOM. It will be part of the layout. It will not be another canvas layer or any other additional element. It will just be the background that you can draw whatever you want on. So I want to show you an example of what that Paint API looks like from initial implementation of the Chrome team. You can see a few really interesting things is that one of the properties, we'll zoom out a bit, one of the properties, offset, is set as a custom variable, and that offset becomes available to the painter. And then we feed off the radius and the fill and a few other custom properties to define the painter, and that painter will draw sort of a chat bubble. And you can see that it feeds off all of these parameters, CSS custom properties, into a custom paint function that draws the background of a text bubble. And it's not done with additional elements, it's not done with additional canvas or images, it's drawn as the actual background of the element. You can draw offsets for the caret, you can do a lot of different things, and this runs completely separately to the main thread, so this is the same as setting a regular background image. This is done as part of the CSS styling and rendering process. Another interesting example that when I saw this, it was really mind-blowing to me because it really underlines how much access you get into the CSS API, into the CSS engine. You're able to control not just positioning or some additional properties that you then render with JavaScript, but really the way your page is rendered. You get really low-level access to the rendering engine, to the layout engine, to the positioning of all these elements. You can see another example, and this is very interesting. We're drawing a QR code completely in CSS. So we define the paint function that generates a QR code, and all we have to do is set a custom property of QR URL, much like content in before or after pseudo elements, and we set the value and we generate a QR. And we don't have to run SVG or any more JavaScript in the main thread. It's not a bunch of divs or a table. It's drawn to the background of the container, and it's done in a very slimmed down version of a worker that is available to the painter, ensuring that these processes, even if processing a QR and painting it is a complex operation, will run in very high performance. Another example, and the third one, is a famous Google ripple effect from material design. If you've ever tried to use any of the polyfills for these elements, you know that they either use Canvas or SVG. They're a bit sluggish. They're very hard to predict in terms of performance. In this example, and it shows not just the ability to render static elements, but to create dynamic animated backgrounds that respond to mouse events, click events, positioning of the pointer. And you can just click around and you get the ripple effect. The ripple is completely contained within the element because it's within the background drawn of the element itself. So you might ask at this point, you've shown us a bunch of cool APIs, but what's the point? Well, there are three, I'd say, goals for the Houdini API, or the Houdini Spec and collection of APIs. The main one is cross-browser compatibility. Let's talk about layout, or box shadow, for example, or text shadow, or any kind of visual API. If it's missing, if it's not available in browsers that you are targeting with your projects today, you can write a very isolated snippet of JavaScript, feed it into a worker, and make that interface available across browsers. That's true, it's only available across browsers that support Houdini. But once we hit a baseline of support for the JavaScript APIs, you will never have a problem of CSS compatibility again. You can implement your own flexbox, you can implement your own border radius, you can do whatever you want, and you won't have to trust adoption of either vendor implementation or adoption by your users of later versions of browsers, or maybe using greenfield browsers. The other benefit is really high-performance styles. So like I mentioned, these snippets, these additional layout engines, they run in completely separate threads. They are registered as workers. And I'm not going to get into workers now because that's more JavaScript land, but they run separate to the main thread on a very slimmed-down subset of JavaScript. which ensures very high performance compared to running masonry on your own or trying to position elements with, I don't know, jQuery or React, and doing this layout in reaction to every browser refresh, to every scroll or position of the mouse or resize of the window. So they happen at a much earlier part of the process and a much lower level of the rendering interface in the browser. And the last bit, that's probably the most creative, is that you can implement your own features. You can really go wild. And you can try maybe adding new things that might be exciting to the CSS spec and add them into a proposal to CSS 4 or 5 or 6. And you can really try and build your own styling, your own style sheets, your own CSS that will fit your projects. So can you use it now? Well, no, you can't. None of this is available. Some mock or reference implementations are available under the Canary flag in Chrome, and you can test them out. You can see the videos, you can see the code behind these reference implementations, but most of this is in the development versions of Chrome and Firefox and Microsoft Safari. Houdini is a very cross-industry team. And it's a lot of effort. There's a lot of effort being made to push the progress of these APIs. What you can do now, though, and that has to do with the fact that we are in a community conference, really is to get involved. Otherwise, I wouldn't be here talking to you about an API that's not available. And this is important because at the end of the day, we're the ones doing web development and web design. We'll be the ones using Houdini. So what we think, what we want, what we don't like, really matters, and it matters to developer advocates of these browsers. It matters to the development teams building Chrome and Firefox and Safari and Edge now. So we should take active part. We should say what we think. This stuff is all on GitHub. All of the official draft report repositories, all of the minutes from the meetings, you can go on and check it out. You can make a pull request. You can open an issue. You can contribute or just say what you think. Yeah, so this is coming, I'd say, probably in the next year or two, but we can help steer the boat. We can make sure that Houdini, this really new and broad change to the way we do CSS, is something that really answers our needs, that is good for us to use as the community, as the people who will be using it probably daily. So yeah, I mean, I just want to make a few thank yous. First of all, to the CSS Conf team for having me. It's a great honor. For you for listening. For the Houdini team, obviously I'm not building this myself, but I'm happy to share my excitement about where the web is going. And that is it. So thank you very much for listening.
Hello? Yeah. Wow.
Awesome.
Thanks, Brock. Remember, Brock flew all the way from London, which is a long goddamn way. And a lot of our speakers have come all the way from Europe also. So when are you heading back? You're heading back on Saturday.
Saturday.
Yeah. So it's a long way to come out to Australia. So give him a big round of applause for doing that. Great job too.
Cheers. Thank you.
How are we feeling? Good? Come on, make some sounds. Yeah. Ah! All right, cool. Where are we at? We're in the afternoon, feeling a little bit tired. We've got some great snacks out there. We've got some baklava, we've got some little sandwiches. We've got more drinks over in the fridges over on the left, if you haven't seen those. We have Summer Snow apple juice, which is a Pink Lady sparkling apple juice, which is an Australian award-winning drink, best non-alcoholic beverage this year, which is quite cool. We've got great chai tea if you haven't had one of those, or a coffee. So anyway, go and have a break, 30 minutes. We got few more talks to go. And then tonight, we're heading to the Panama Dining Room, which is in Smith Street, in Collingwood. So you've got an hour from when we finish until then. We'll have dinner and drinks there. It's not a full meal, but it should be enough for you. If you have a partner or someone, a +1, something like that, totally bring them along, and we'll have a good ass time there as well. All right, see you back in 30 minutes.
All right, thanks everyone. I hope you had a good break. We're about to kick it off with a couple more talks. So again, it is with great pleasure that I'm here to introduce our next speaker, Jose Perez. He's a web developer at Spotify, working out of Stockholm, Sweden. And if you follow him on Twitter or read his blog at all, I'm sure you're aware that he's super passionate about web performance. So fittingly enough, he's here today to talk to us about progressive image loading. So please join me in welcoming Jose.
Cool. Sorry. Yeah, that looks fine. Hello, everyone. I'm super happy to be here. Thank you a lot to the organizers. It's been an amazing conference so far. I'm here to be talking about images and what we can do about loading images on the web. I consider we developers, we like to discuss about CSS and JavaScript and what's the latest library and framework, whether we can use React or we can replace it with React in order to save some bytes here and there. And sometimes we forget about images, and I'm going to be talking about why it's important that we keep an eye on images. Images on the web are a huge stake. They represent 2/3 of the bytes that we are sending down the wire whenever we load a page. That's more than anything, more than videos, audio, JavaScript, CSS, all together. And it has an influence on the time it takes our page to load. Something that we should question ourselves whenever we are told to use an image is whether we should or we shouldn't. For me, it would be very easy to just say, don't use an image, and then you have all the problems solved. But of course, that's not the solution. But maybe we can try to adopt some of these design trends that we are seeing nowadays more and more, about using minimalist design or flat design. And normally they focus on serving vector images and maybe 1 or 2 big bitmap images. And that's very good for performance, because these vector images are normally very small, and also it's also good for your code repositories. You don't need to be creating several sizes of the images and store them in your repo, and maybe also store the PSD file that you use in order to create those files. So it's a good idea to try to embrace that. But of course, that's not always the case, that you can change the design. And in some cases, it might be as easy as just trying to remove a request for an image that is not needed. I'm going to show you a real example of a page I work on. This is Spotify website for, this is a page for a song on Spotify's website. And well, it's a bit difficult to see, but there's a background image with a picture of Adele there, that it will be visible in a wide screen. But when we serve this to a mobile phone, the user will see something like this. And you can't appreciate anything in the background. So that image that we had there, this screen looks a bit dark, it gets cropped and it doesn't really provide any value. So maybe at this point, we should just remove it. We don't need it there. We can replace it with a gradient or a solid color instead. And someone might think that we can hide it just using a media query and setting the display none. And that will hide it, but the browser will still make the request. So you are fixing it only in one side, which is not showing it. But the browser will see the image tag, and it will send the request regardless of what you say in your CSS. Another way that we can also make this mistake is by trying to hide a bigger chunk of markup. So here we have a couple of sections. The second one is hidden, but the image within that section will be requested. And there are ways we can prevent this. And one way would be to use some kind of template engine for printing this, rendering this on the DOM, or if you use some component library, that will usually take care of that. So you don't need to make a huge amount of changes in your design. Sometimes it's a matter of being a bit careful about what your page is really requesting, and we will see more of those examples. Once we know that we want to load a certain image, the next thing we have to do is optimize it. And normally there are trade-offs. Whenever someone tells you this is the best thing, there's always something that they are not telling you, but I can't find any problem with optimizing your images, really. Just do it. There are many tools. Normally I use image optim, but there are some other tools that you can also include in your build pipeline, and they will make the job. The good thing about saving these bytes is that suddenly you have more bandwidth for the rest of the assets that are competing when you are loading the page. So maybe your JavaScript and the CSS will be delivered slightly faster. So you gain in two different ways. And there are tools that will carry out some lossless compression, but there are also these days more tools that are doing lossy compression, and they use a structural similarity to create variants of the same image, and then it will pick one that is close enough to the original one. And you don't need to set, I want this JPEG to be compressed at 80%. It can be dynamically adjusted depending on the image, and you get lots of savings. A third thing that we can do is to use the picture element and source set and sizes attributes. At last, we have a way to implement responsive design, and the thing is that I don't see many sites using it. And to be honest, I don't use it myself. I find a couple of problems with it. And I like to listen to the people that are working on the standards and how they propose this. And then I also like to see how developers are trying to put it in practice. The first thing I personally don't like is that the code can get a bit bloated. There are also this coupling between your markup and these media queries that you might have set on CSS. So you have to be very diligent trying to keep both in sync. It's very easy to make a change in the design in the CSS and forget that you had certain images there that were relying on certain breakpoints. And that's needed by the picture element, or in this case, the image with sizes and source set, because the browser has to have this information in order to know exactly what image it has to request. It's like that. But I would like it to be a bit different. Maybe, given this area, try to find the image that fits that area. But for that, we need the CSS to be in place. The second issue is lazy loading. We still don't have any standard solution for this. We can save so many bytes by just not requesting the images that the user is never going to see. Most of the users go to the page, and they see something and they click around, but they don't scroll to the bottom. However, we are requesting all the images until the bottom. What I've seen working pretty well in practice is to have some content above the fold that uses regular images or a picture element, and then the content that you know is going to be below the fold. In this case, it's rather easy because it's a page that is optimized for mobile. That content below the fold, you apply some lazy loading. And it's savings for everyone. It's savings for the user because they don't need to spend the data on that. And if you're using the CDN, it's also savings for you because you don't have to pay for the CDN for those images that you never serve. Lazy loading is a bit tricky. When done well, it works. When done bad, it can backfire. The basic approach for doing lazy loading is to go through all the images and then check whether they are in the viewport or not. You can also check if they are close enough to the viewport, so you request them because you know that as soon as the user scrolls, they will be in the viewport. And then you have to do this every time you scroll, of course. And then also every time you resize, because resizing can also change the layout, and then new images can appear there. This is really expensive if you just implement it blindly and you listen to all scroll and resize events and check the dimensions of every image. That's going to be invalidating the layout cache for the browser, and the browser has to do extra job every time one of these events is triggered. So if you implement it, try to throttle it. There's a new API. We were talking before about new APIs coming to the browsers. This intersectional server is a really nice one that is already on Chrome and Opera. Instead of listening to the scroll event, you subscribe to events that are triggered by that image. That is not an image anymore. You will be using some div, otherwise it will be making the request. But you listen to that, and then whenever it appears on the screen, you will get an event back. As I said, it's supported on Chrome and Opera, and it's under development on other browsers. And it's very easy to implement a wrapper that uses one or the other. And this is an example. I think it's best if we see it here. So there we get events when that green square is on the screen. But not only on the outer scrollable window, but also in the div that is also scrollable. So it's pretty nice. And it can also be used for rendering virtual lists of lots of elements, not only for lazy loading. Now the interesting thing is, okay, we know we are going to request an image, but what do we show while we are requesting the image? I think that this is really interesting. There are different things that we can do here. The default one is not doing anything at all. We just save the space there. The browser will make a request, and it will come back. The second one is to use a placeholder. This might be useful if you have like a user page and you have a profile image. You can use that, and then if the image for the user is not set, then you can display this one, or you can just show this one until the image is fetched. And normally you would implement this using some SVG. The third one is to just use a color, background color. This is really useful if you are rendering text that has the same color as the background, and you rely on some image to be in the middle. So imagine our background is white and the text is white, but we are going to be putting a background image behind the text. Until we don't have that background, the text won't be shown because it's white as the background of the body. So it's a good idea to use one of the colors that are in the image to serve as a placeholder. And normally there are also tools that you can use, libraries that you can use to give you a palette of different colors that you can use. And the last option, which we will be exploring a bit more, is to use a blurry image. So you use a smaller version of the image and you serve that. And we will see how some sites are using it in practice. I'm going to be talking about the two last ones, because I think those are the most interesting ones and the ones that are trying to improve the user perceived performance of the site. So as examples of solid color, first I'm going to show this one. This is the Chrome browser that whenever it detects that the user is on a slow network, they offer the possibility to hide all images, actually not request those images, use dominant color from the image, and then you have the possibility of tapping in that button to load them. This is really important in countries where the internet connection is super expensive. But they use this also in some other sites that are more normal. This is arts and culture, and it's a site that they built for browsing collections of museums. And here you can see, okay, you can barely see it. The color is very pale, but they show some placeholders. The good thing about those placeholders is that they give feedback to the user. So you know that something's going on, that the request already went out and you are waiting for the images to come back. You also get an idea of the size of the image and the color. But you don't need to use one of these weird scenarios. You can just search on Google Images. This video was recorded using a throttle network, and that's why we see lots of these placeholders. but you get the idea. So that's supposed to improve the user-perceived performance of the images. Then if we see examples of progressive image loading, it's also called blur up technique. There's one that I think they are doing it a lot. I don't know if they are doing it well or not, but they are doing it, and that's medium. So whenever you go to a medium post and you see an image, they will load it like this. Then they will transition. So first there's no image, then they request a small one that they use to blurry and scale up, and then finally they fade in the big one. And that's a film strip of the process. So this is not straightforward. There are lots of technicalities behind it. They use a div to render the image. If they were to use an image, then the image is already requested. There's nothing to do there. They request the small one. They draw the small one into a canvas, and then they apply a blur effect. You can also achieve the same behavior by using CSS filters, and they have also blur there, and also there's a blur filter on SVG. Not sure why they chose canvas, but it's very creative. Then they request a large image, and then when it's fetched, they render that one and they hide the canvas. And this is the overview of the markup. So if you want to implement something like this, you will need to have several things into account. So there's a div there that is going to keep the aspect ratio of the image. There's the initial small image, there's the canvas, there's the final image, and there's a no script because they care about users that don't have JavaScript enabled. Then the question is it worth it, or how do users see it? And here we have people that on Twitter, they say that they like it. It looks nice, or it loads very fast. Then you also have people that say it's very distracting, and that it loads extremely slow. And this is very subjective, and it's a problem. I'm not going to say, this is great, guys. False. I can't really say that, because people are going to perceive it in a different way. And this is not surprising. We have had something similar for a long time, which is progressive JPEGs. So there you can see how at 30% of the bytes downloaded, we have already rendered the whole area. Even if it's with lots of pixels, at least we can draw the whole image. In theory, this is nice. In practice, there's a study that I found, the only study that I've seen that carried out this research, that said that cognitive fluency is inhibited and the brain has to work slightly harder to make sense of what's being displayed. So these progressive images are a bit harder for the user to process. And there's only 7% of the JPEG images used on the web are progressive, only 7%. So that tells us something. Then this technique can also backfire. There it's very small, but it says, if you are viewing this on desktop and the above image looks a bit blurry, please refresh the page. So instead of ending up with the normal image, we are ending up with the blurry one. So something broke in between. And Sarah also reported something similar. So it's very creative, but it can also backfire. So if you implement something like this, just be careful. Medium are not the only ones using this. Facebook are also doing something similar for the mobile client. And they wanted to inline the initial thumbnail, and they wanted to make it super small, so it was part of the payload, the initial payload served by the GraphQL. So whenever you visited the user's profile page, there was a request to the service, and then the response would already contain the image. So you don't need to make another trip to get the full image to render something. And they decided that a good value for the size of the image would be 200 bytes. But there's a problem with JPEG, and it's that only the headers of a JPEG image is already bigger than that. So these are also very creative people, and they decided that, okay, let's try to find the common header for all the images, store that in the mobile client, and then serve only the compressed data. And then we put it together later on. So just so you see how several companies are trying to really make this super performant, especially in countries where they have very slow networks. And this is super creative, and I was wondering, okay, let's give it a try. Let's see how small I can make a JPEG. And I used images that were 42 by 42 pixels, which are the same size that they report. And I make them, I compress them at maximum. And yeah, they were right. They are bigger than 200 bytes. Then I started playing with GIF, PNG, and whatnot. And I thought, yeah, well, let's use WebP. And it turns out that WebP is really nice for encoding small images. And it actually, except for this image on the rightmost, they are way smaller than 200 bytes. And they are roughly 25% of the size of a JPEG. And one might say that the images are not exactly the same. They don't have the same artifacts. But these are images that are going to be used for applying a blur effect on it. And then when you apply that effect, they look mostly the same. So yeah, at some point we might want to be creative, but we also need to be aware of all the new formats and new APIs that appear, because maybe it's a moment to embrace them. And yeah, last but not least, I like SVGs. We've seen how powerful they are. And I was seeing this page. I don't know if you've seen it. It's a review of a PlayStation on Polygon's site. They also did a review for Xbox One. And I really like how they were drawing on SVG. And then I started playing with it, and I said, okay, let's try to reproduce it. And you can use any SVG by applying a certain transition to the stroke dash offset, you will get this drawing effect. But what does this have to do with loading bitmap images? Well, it turns out that we can use something for loading these bitmap images, which is detecting the edges. So instead of trying to vectorize the image, we can try to draw the edge. And there are implementations of this algorithm in JavaScript. And then you can do something like this. So imagine that instead of serving a small version of the image, you serve SVG. These SVGs are 3-4 kilobytes. So they can be inline. And you can be drawing them while you load the big image. I don't know how useful it is, but it's kind of fun seeing something around there. And you can drop any image, and it will just work. And you can define how many lines you want to use, or how big the SVG you want it to be. And the way this is done is, as I explained, you find the edges using a certain algorithm, and then you create lines. These lines, in my case, I chose polylines, but you can also use paths in SVGs. And then once you have the SVG, then you use the same technique to draw it. It's a no-brainer. So should we do this? Just because you can, it doesn't mean you should. It's like these people that say that if it can be done using JavaScript, it will be done using JavaScript. And you see terminals, you see almost operating systems implemented in JavaScript. And people do it for fun. But I think the web is fun. It's intrinsically fun. It's open. We can all right-click and inspect the element. And that's how I learn web. And that's how everyone can learn about these techniques. And it's open by default. The code doesn't live compiled behind some weird package. So just go out and experiment with this and try these techniques. Why not? I mean, as long as they are easily revertible. So if you use something crazy like, well, not crazy, something like what they are doing at Medium, that's completely right. Eventually, they might move to something else. But as long as it's something that they can decide from one day to the other, why not? Let's try new things. And yeah, that was my talk. Thank you very much.
Well, thank you very much. The web is fun, isn't it? It's a very good way to end the talk, so thank you. Our next speaker is busy in so many areas and has so many amazing side projects that I'm probably going to fail in trying to list them all, but I'll try to highlight a few things. Well, first of all, in her day work, she works as a digital product designer at Bank of New Zealand. And New Zealand is also where Serena Chan is coming from today. But she also does a lot of other things. For example, she mentors women to participate in the tech scene with her works at Rails Girls, which I attended once, and I think it's a great initiative. She also started a funny, feminist, actually really entertaining and smart online magazine called Hungry, spelled with a V, mag.com, and I encourage you to visit it. It's super interesting, and it's for teenage girls mostly, but I love it, I read it, highly recommend it. She also tackled another important issue in our industry, which is there are a lot of podcasts that consist of dudes talking to each other for 2 hours. So she started her own, which is called Things of Interest. And I encourage you, especially people who have long flights home ahead of them, to download a few episodes and listening to them, because it is really interesting. And as if that wasn't impressive enough, Serena is actually a physicist by trade and has written a thesis on quantum physics. And I was going to quote the title, but I can't pronounce half of the words in there. However, what I can pronounce really well is the German word Gedankenexperiment, which is what Serena is going to conduct today. And who could we possibly trust more in talking about the ideal styling language? Please put your hands together for Serena.
Hello, wow. Thank you so much for that intro. So today we're going to be embarking on a little thought experiment about how our ideal version of CSS might look like. But before we get to that, let's go through some background. Now, I started making websites, like a lot of you in the audience, a while ago, like in the late 90s, just a few years after the first CSS spec was rolled out. And as you might know, the web was a very, very different place back then. So the old internet was made for documents. And when you think about the weird, annoying things about CSS, like global scope, in the world of documents, it actually makes a lot of sense. But nowadays, people of the web have changed. Even as soon as 5 years ago, having your own style sheet for your favorite websites on the web was not an unheard of thing. And web development itself has changed. The DOM is no longer static, and I'm pretty sure I spend most of my time troubleshooting NPM and Node instead of writing like actual HTML and CSS. So it's a wild, wild world we live in. So in the last 20 years, we have been molding CSS to fit our needs. In 2006, SAS was released, and it blew all of our minds. Does anyone remember the first time they heard about SAS? 'Cause I do, and it was great. Changed my life. Post-CSS meant that our poor fingers didn't have to type out every single browser prefix. And CSS Modules meant the end to global namespaces. We're actually using it at work at the moment to build stateless functional components, and it's a beautiful world. And I'm not even mentioning here the like 5 bajillion different namespacing conventions out there, but it's out there. And in this list, you might start to see a pattern. We're increasingly tacking on more and more solutions, more and more conventions, more and more toolkits. But in the midst of all this tooling, we're taking our mental capacity and focusing it on something that's not actually making websites. It's making the act of making websites nice and easy. And in the midst of all this tooling, the core pain point of CSS is still the same. It's hard to write maintainable CSS at scale. Now, what does this mean? It means lack of scope. Global scope might be fine for a weekend project, but as soon as you work with someone else, as soon as you work on a large project with hundreds of views, it becomes really unbearable. It means confusion around which rules apply to which element and which rules don't. How am I supposed to maintain something if I have no idea what changing this piece of CSS will do to some obscure page that no one sees anymore? And of course, the list goes on, and I'm kind of preaching to the choir here. I'm sure we've all had our own battles with CSS, things like dead code removal from the talk before, just things like working with other people. And by other people, I mean yourself 6 months ago. Just doing something as simple as that is really difficult. But I think that these two distill the core problems of maintainable CSS at scale. And if you look closely at these problems, you can see a common symptom. They both lead to specificity wars. So if we're talking about an optimal styling language, we would do very well to eliminate specificity wars once and for all. And the reason is this. It doesn't matter how much good practice we know. It doesn't matter how diligent we are in the best way to architecture our CSS. As soon as you get into a specificity war, all of that comes off the table, and the importance come out. We've all been there, we've all done that. And since this is such a core problem with CSS that touches on everything from the cascade to selectors to scope to inheritance, solving this should solve a really good chunk of our most fundamental problems with CSS. So now that we have our ideal styling language and we know what it should, well, we don't have it yet, but we know what it should solve, let's go ahead and embark on this thought experiment. What would CSS look like if it were written today? Probably JavaScript. I mean, I kind of want to touch on JavaScript just as an aside, because it's such a massive pillar of our current web development landscape. And as a disclaimer, I have no beef with JavaScript. I am loving CSS Modules. I think it is doing exactly what we need, and it is filling the gaps that the old web left behind. But if we take our current trajectory of web development and take it to its logical conclusion, web development is going to simply be JavaScript development. And this is not necessarily a bad thing, except when it is. You see, the reason the web is so proliferant and successful is because it's accessible. You can access from any device, anywhere. It degrades gracefully if you have JavaScript turned off. If your web browser doesn't understand what CSS is, it's fine, you still get the content. And this accessibility is made possible because we separate content, style, and logic. So while JavaScript is really awesome for now, we have to keep in mind and be careful about which direction we're heading in the future. And always bear in mind that accessibility is compulsory for the web, not just a nice to have. So with my JavaScript rant done, we can go on to looking at the ideal styling language. I'm going to break this up into what I see as three core culprits to specificity wars. The first being the cascade. So what does our ideal cascade look like? Well, first of all, who here actually knows what the cascade is? I know, like, really weird question to ask at a CSS conference, but the many web developers that I've met, including myself, have confused the cascade with the specificity algorithm, with inheritance, and I thought that for the longest time too. But it's neither of those, and what it actually is how the browser decides which rules take precedent depending on where they come from. So here is the order. So when your browser is passing through your HTML and your DOM, it takes an element and it filters out all the rules that don't apply and is left with all the rules that apply to the element that it's looking at right now. Then it performs the cascade algorithm, and it orders all these rules based on where they come from. So the lowest precedent here is the user agent style sheets, which is your browser style sheets, essentially. And then the next one are the user style sheets. So if you want to get creative, if you want to put your own style sheets in your browser, that's where it sits in the cascade. The one above is the author style sheets. This is where your CSS as a web developer lies. And in between that is CSS animations, which sits there, in case you were wondering. It doesn't cascade. And after that are the important declarations for author and user, but flipped around the other way. Now this is really important because it explains why if someone else has used an important declaration, you can't just make a more specific selector, because the cascade algorithm happens before the specificity algorithm. So it doesn't matter how specific you make it. If someone else has got an important somewhere, it's going to override your thing. So this is the thing. A lot of web developers, and I'm betting on most web developers, not knowing what exactly the cascade is. And we fear what we don't know. We're afraid of the cascade. And this confusion will cause the classic important declarations coming up everywhere and ruining our lives. So I had a long, deep think about how the cascade could be better. And you know what? The cascade is actually really good. We need a way to resolve conflicting rules coming from different origins. And when we think about it, I think we all have a really good idea of where the problem is. It's those important declarations. So let's just remove it. It's our thought experiment. We can do what we want. So look at that. Beautiful, brand new world. But this causes another issue, which is that in a world without importance, suddenly we have to write good selectors. We can't just important stuff away. So let's look at the ideal selector. Now, what do we want? We want separation of concerns. We don't want a selector that basically regurgitates the DOM structure, but we also don't want a selector we don't want to use so many classes in our markup that we're regurgitating style information in our markup. We want reusability. We don't want to spend all our day copy-pasting, fair enough, but also we don't want the user to download 14 different copies of the same border radius decoration. I've been on GPRS internet. It sucks. You don't want that. And we want efficiency. We want to be able to target only the elements that we want as fast and as unambiguously as we can. So as an example, let's look at BEM versus atomic CSS. So BEM is basically just a namespacing convention where your components define your classes. Declarations inside that component aren't reused elsewhere, which is nice because it keeps your code nice and tight and encapsulated. Atomic, on the other hand, is way on the other end of the spectrum. The philosophy is that classes should be general purpose. They should be reused. They should define common rule sets, and you should be able to apply them to whatever element, whenever. And you can use them over and over again. Atomic CSS is really awesome for lightning fast prototyping. And I know that there's many in the web development community that think this is weird. I used to think it was super weird, but I highly recommend giving it a go, trying it out, because it really is a great time. Where it fails is it fails to separate content and style. When you have so many classes being reused, you're essentially putting style information in your markup, and that's a problem. You're also repeating yourself a lot because you're calling, 10, 20 different styles in the same element. On the other hand, BEM doesn't have that. There's no styling in the markup, you don't repeat classes. But when you look at the CSS, there's a lot of heavy repetition because you can't reuse the code across components. In many cases, you also see a lot of DOM information encoded in the CSS, which is, again, bad. So we seem to have reached an impasse with our ideal selector. We can't have reusability and separations at the same time. Or can we? This is where I want to take some inspiration from Sass. Many of you will recognize the syntax. You define a function for a bit of code that you want to reuse over and over again, and you just call it to reuse that piece of code. Awesome. It saves repetition and development, but what happens when we put it in native CSS? It becomes incredibly powerful. So here I'm defining two rule sets that I want to reuse over and over again that are related. And at the bottom, I'm calling those rule sets on some kind of selector, very simple selector. Notice here that I'm not making many classes to be reused. I'm just making one class, so there's going to be no styling in the markup. But at the same time, I can reuse as much code as I want, natively. And in fact, come at me efficiency. I'm free to use the ID selector. What? Remember how we never use IDs because they're by definition one-time use things? Well, not anymore. We can be as explicit and as efficient as we want and still be able to reuse blocks of code. No styling and markup? Check. Highly reusable code? Check. Letting our hair down and using some IDs? Check. Moving right along. So what would our ideal scope look like? Well, as it turns out, scoping in CSS is looking to be pretty straightforward. The upcoming CSS4 spec introduces a scope shooter class in which you can set your own local scope. Very exciting. And to protect your scope from inheriting random other things that other people might have made, you can use all initial to reset every CSS property to their browser defaults. And if that's super hardcore for you, you can also reset specific properties to their initial defaults. The real problem isn't so much the scope as it is working in a hostile environment. And when I say hostile environment, I mean that one client that you took on that needed you to just customize a WordPress theme that was already there, and you weren't allowed to touch the markup, you weren't allowed to touch their CSS, you maybe even just had a teeny wee custom CSS box in which to put your code in. I'm sure we've all been there. So this is a tricky case because it doesn't matter how good we are. No amount of well-defined scope or really beautifully crafted selectors will stop someone else from directly targeting the element that you work on. So what do? Remember this guy? And our beautiful, simple cascade? What if we just did this? And what if a framework CSS sits here? What if your third-party CSS sits here? And what if your CSS sits here? Interesting. And I know what some of you might be thinking already, looking at this. You're thinking this could probably very easily turn into this. But there's a quick fix for that. We can do that by directly setting the parent that it overrides. So you can never declare your code to be the most important code. You can only say how important your code is relative to the code that's already there. So someone else can always come in and overwrite your CSS if they want to. So yeah, it's not perfect, can totally be abused, but at least it works. When you slap on an important to one of your declarations, you're not guaranteed that it's going to work, especially if you're in a hostile environment where everyone else is using important declarations. But the thing is, I'm not too worried about the specifics of how this idea might work, because the important part is that it encourages developers to actually interact with the cascade, something that we've never really done before. And when we interact with the cascade, we therefore educate ourselves about the cascade. We get rid of the fear around the unknown. Now you know exactly where in the cascade you sit and why. So what does this all mean for us right now in the real world? The cascade is a powerful thing, and everyone is ignoring it. And maybe we should not ignore it. CSS4 spec is really exciting. We're getting variables, we're getting scope, and the cool thing is a lot of it has already been implemented in Firefox and Chrome, so go ahead, play with it, have fun. As long as you don't need to support IE or Etch, you're sweet. Classic web development. SAS 3.1 now supports first-class functions, which is also really exciting, because I'm really intrigued what CSS might look like as a fully fledged functional programming language. We're not quite there yet, but there's a lot of exciting stuff happening, as you probably heard from the previous talks. So yeah, play around, get involved. The whole BEM versus atomic schools of thought, that's like tabs and spaces, pros and cons. Try both of them out. Don't just go with one blindedly. And really importantly, we need to keep the separation of content, style, and logic. And what we need to do that is to have good interfacing between those. Kudos to Barak's talk before. That blew my mind. That was awesome. So that Houdini API has got me really excited about the future. But the main thing that I learned while going on this long journey of thought experiments and wild ideas and throwing random shit at the wall is that CSS is not dead. When I started this, I was thinking, oh, there's so many massive problems in CSS. This must mean that it needs massive change. And I was wrong. A lot of the strange things that CSS does is based on good decisions and consideration for wider context than just web development. So maybe it's time to reignite our CSS love. Maybe after our struggle of over-tooling and band-aiding, we can appreciate CSS for what it is and what it does for us. And then we can get involved. We can make sure it keeps working for us and for the future of web development. Cool. Thanks, everyone.
Thank you so much, Serena. I think we'll all have plenty of food for discussion in the upcoming break, right? So outside there's tea waiting for you. Have a little break, have some good conversations, and we'll see you back in here for our final talk of the CSS Conf at 5:10.
Let's do this. It's the last talk of the day. I hope everyone's had enough sugar and is feeling good. So our next speaker is a front-end developer and has been working on the web for nearly 13 years, since 2003. Oh, I've got a backing track, awesome. And Petra has most recently finished up working on a big project at the DTO, and for those of you that don't know, it's the government driving the digital transformation of government information and services, making them simpler, clearer and faster for everyone. So it's a huge undertaking, and Petra's going to talk to us today about building a living style guide and how the team overcame all of the challenges that go with working with government and government agencies. So this should be a good one. Welcome Petra Gulisha to the stage.
Hello, everybody. First of all, you're all a bunch of champs. Thank you for sticking it out today, and I'm glad that I can be here for the final talk of the day. I'd like to share some lessons that I learnt and shared with the team working on the design guide project at the DTO, you might know it as. So let's get going. I'm Petch. I am a product engineer and I work for a design studio called Us2. Product engineer means that I help build products and the systems that deliver the products, and I do that on the web because I like it. I'm from Sydney in Australia, which is not far from here. Melbourne's nice too, I guess. Us2, we call ourselves a digital product studio, which means that we launch products, services, even our own companies. We've got 4 studios around the world, and Sydney's the smallest and the youngest with a baby. We've only got about 30 people. But we've worked with already brands and with startups and now with the government launching products that have some kind of impact on the world. You might know Us2 by this game, Monument Valley. It came out about 2-ish years ago, and it's been downloaded about 26 million times, which is once for every man, woman and child in Australia, and a few dogs as well. So I started working with the DTA about 6 months ago on their digital style guide project. The DTA was established in 2015, as Mel said, to help government departments and agencies transform their services to make them work better, more gooder. They've got teams in Canberra and in Sydney, and they've grown to about 100 people, maybe? A lot of people doing really great work. Government services, they work on stuff like if you need to book an appointment with the Department of Immigration, that sounds like a simple thing to do. The DTA works with the department to make sure that that online service is as simple and as clear as it can be. They've also worked on attendance records for childcare services with the Department of Education and Training. Stuff that touches people's lives on the reg makes a big difference if they work better. So we've got this handy 13-point guide which helps us deliver simpler, clearer and faster digital services. There's a lot of words up there and it's a wonderful guide to follow while you're delivering projects. But what it boils down to is follow a guide. So we made one. Because the DTO has a philosophy that says deliver quickly, learn, and then iterate. Delivering quickly means that you want to have as little waste as possible in every project, and so that's where a style guide can help. Our team formed to build a CSS framework and piece of documentation to help teams at the DTO get up and running as quickly as possible on their projects. So this is what we came up with. It's screen reader ready. It doesn't look very glamorous, but it's quite small and it's fully WCAG compliant, and it works like almost everywhere, which is hard work. But why build a style guide in the first place? I don't think that all of the government websites should look the same, because that would be a bit boring. And I'm not going to try and sell you on the value of building a style guide, because a lot has been said about why that's probably a good idea. But what I will talk about is why making a style guide helps us deliver simpler, clearer, and faster digital services for government. Government is really complicated. It's a complicated machine. It's big. The Australian federal government has 18 departments and 192 agencies, resulting in thousands and thousands of websites. So you can imagine there's a lot of redundancy in the way that things are built, and a lot of overhead, both for citizens that have to interface with government agencies, and of course for the departments that are maintaining these websites. Simply bringing things online doesn't necessarily make them more efficient. Government is for everyone. That's why government exists. So when you're building an online government service, you have an audience size of everybody. So that it kind of you've got to make sure it works for everyone, everywhere, which is a bit of a challenge. Go back. There we go. Case study in device support. So it's like responsive is not a new thing anymore. We do it pretty well. We know about connectivity problems. Even though a lot of us sit on a laptop or a nice big screen, things look real nice. We're aware of all of the other devices that people use to access the internet. And of course, that means we're presented with accessibility problems, or opportunities, shall I say. People have different levels of connectivity. They've got different types of attention when they're interfacing with your online service. So we can be real good developers, and we can make sure that we've got all these use cases covered off. But what about when someone looks at your website with a Nintendo Wii? Because that happens. 5,000 sessions on the ATO website last year via a Nintendo Wii. So, cool, good on that. And of course that doesn't mean that we're now just building websites for the Nintendo Wii, because that would be a bit weird. But it's a nice reminder that sometimes people are using devices that you wouldn't expect, and it's not always out of choice too. People have older Android devices that maybe can't be upgraded. And if something works on the Wii, it's probably going to work on any new device that comes out too. So you've really got to broaden your scope of thinking and think about the user, not about the device. So I'm going to talk about some do's and don'ts. The design guide project, I was working on it for about 6 months, and we went from we probably need a design guide to working software over that period of time. But of course it had its unique challenges, and we learnt some lessons, so I'm going to try and share some of them with you. Number one, don't work in a bubble. The number one thing that I took away from working on this project was that design systems take a lot of people to build. And even though our team had research capability, design capability, development, we were in no position at all to tell the whole of the organisation how and in what style they should build their interfaces. What we needed to do was constantly be in touch with all of the other teams, find out what they were building, what worked for them and what didn't, and make sure that we were friendly and happy, and try and be a bit funny in the change logs, and make sure that people always feel happy to come to you. You've got to be flexible. Like, we had a remote team the entire time, so we did most of our hangouts on Slack, and we would just work wherever we could find a Wi-Fi. So don't work in a bubble, collaborate. Do test early and test often. That's my life motto. I've got a picture up here of our very early workshopping session where we defined the MVP of what this design guide would look like. And so that, given that that was our first deliverable, what we initially had to do was define what that product would look like, what's in it, who are the people that are going to use it, and what do we think we know about what they need to get out of our product. So by the time we made our first release a couple of weeks in, we already had something ready to test with a set of hypotheses and challenge our assumptions about the product. As an example, we assumed that the best model to deliver a CSS framework was a little snippet of CSS, a little snippet of markup, a bit of information about how to do it right. Turns out, a lot of the developers don't have control over the markup that they're putting into screens. Maybe the markup is coming from another back-end system. How do we accommodate that? We've got the tools and the smarts to do it. Of course, we were not just testing with users, but we were testing the code itself. So we always made sure that that we had any automated tests we possibly could for accessibility. We'd check on things like our file size. You'll notice that I haven't actually talked about any CSS yet. But now we do the extend thing, or don't, as the case may be. Result of some of our testing, turns out we've ended up with a real big style sheet. It's not so great for performance, just a bad idea generally. We found out that extend was not working in our favor, decided not to use it. And that's okay, that's a decision that we made as a team, and that's a lesson that we learnt. But because we had these tests in place, we were able to figure out really quickly that something was going wrong, fix it, and get on with our lives. Of course, that started to raise questions about our architecture too. Do we need conventions to stop us from implementing anti-patterns, maybe? Architecture as you go. When we started out, we didn't know what the design system would look like. We were developing a design system and also coding a framework to deliver it. So what that meant was we had to decide one piece at a time what the structure would be. And so the first piece was typography. You know, what does a heading look like? What fonts are we using? What is our line spacing? And so on and so forth. And as each time we added a new piece, we say, well, how does it fit? And how does it change the things that we've already got in place? So it was nice and lean. We had enough structure to inform the rest of the teams, but nothing that would ever constrain us. The key was flexibility. So you can see we started out with just a partial for a whole bunch of things that you might find on a page. And then as we go on, we started to get a little bit more serious about, oh, well, maybe this is a component and this is a utility. Of course, that means that we can manage the dependencies within our imports a lot more easily. But we only added that complexity as it was required. Everything that you produce at the DTA is open source because it's a really nice way to work, having your code out in the open. And I know what an open source project is, I think. That means that you've got an open repo, means you've got contributing guidelines, you've got a really nice README, probably got some templates in your pull requests and your issues. So that was all going great until we realized that we actually didn't have the time or the capability to deal with feature requests that came in. So even though we were deciding for weeks on end that, oh yeah, it's okay if another team develops a feature, they test it and they bring it back to us, we'll just slot that right back in. Unfortunately, we had a crisis of confidence. We didn't know, is this the button that we want for everyone? We had to define our own product and our own roadmap before we knew what we could fold back in. So I think the effort of implementing a community, or rather managing a community of open source contributors, means that you have to have a really, really strong belief in what you're building and where you want it to go. Unfortunately, we ended up with pull requests that would just sit open for weeks and weeks and eventually months, which is just horrific, because we couldn't have the confidence in our own product to make a call on whether this thing should be in or out. Maybe someone should have just merged it, I don't know. Alli this morning, she said that having good markup means that your page, your document has meaning without any styles at all. And that was a philosophy that we followed on this project from the very beginning. So when we came to look at things in, you know, IE7 and IE6, because it's government and people still use IE6 and IE7. Actually, no, I think we ruled out IE6. Yeah, I think we did. But IE7, still there, still a lot of that. And the best way that we could deliver quick value to those older browsers was just by ripping out the style sheets completely. And because we had a well-structured document, every component that we added to this style guide had guidance on which what are they called again? Tags, elements? HTML, how does it work? I don't know. We gave guidance about what the semantic meaning of each of those elements are. Do you have to apply a role to it, or Any extra attributes to give it more meaning? Yes or no? Of course, no style sheets is not really a solution that's going to cut it, because the internet would just look like 1998 if it did. So once we focused our efforts on producing styles as enhancement instead of working on fallback, we found that we could provide a better experience for less capable browsers and also give all of the sugar to new ones. So, how did we do it? It's a real minefield out there, and now we get to write the actual code. Code comments plus gulp is a style guide, basically. Because we wanted to deliver the first iteration of this style guide so quickly, and we wanted it to be a living style guide, we said, all right, we don't want to be developing two products. We don't want to develop a CSS framework over here and then develop a guide over here. Let's join them. And so did a bit of Googling, found this thing called KSS, which is a syntax for CSS comments. And then thanks to a nifty little node generator that runs on a gulp task, we take all of the comments out of our CSS and build them into a static site, which was real cool. So the comments, oh, that's terrible contrast. Probably not AA compliant. So in our buttons partial, we used Sass, by the way, because it's pretty handy. In our buttons partial, above all of the styles that describe what a button should look like, we have a comment block, and it says creating buttons. We've got some markdown content there. We've got a link to an HTML, or rather a path to an HTML file that contains the markup that matches these styles. And then we say, where in the style guide does it live? It lives in the buttons section. And once we pass it through the sausage machine, we get a page on the style guide called buttons. There's a section there called creating buttons. And then all of our content is there, all of the different types of buttons you can have. It's wild. And then your markup sample there. And there's a link back to GitHub so that you can raise an issue or dig through the code or whatever you fancy. So that got us up and running really, really quickly. And it meant that any time we were editing styles, we were editing the documentation and therefore updating the guide. And as the project went on, we found that that had its limitations because we couldn't just make a page like you would expect to be able to do on a website. So when it came time, we swapped out our Node KSS builder for a Jekyll build. But we had the same principle. We took all of those comments out of our CSS into a data object, put them through a different sausage machine, and spat out a Jekyll static site at the end. Same principle, worked really well. This is the digital marketplace website, which was one of the first adopters of the digital style guide. They went from 0 to beta in, I think, 2 months, less than 3 months for show. And they were really key, this team, in bringing new features back into the UI kit and also helping us test out the features that we put in. So what we ended up with was a tool that helped teams at the DTA deliver really, really quick prototypes instead of having to design, test a new login pattern every time you launch a new project. You can go to the design guide and say, what does a login screen look like? The marketplace and other projects were able to launch incredibly quickly and not have to worry about their browser testing or their accessibility testing. They knew that they had a baseline of support. And the new DTA website, which was just launched last week, there was a name change, get a new website. That was built in just 2 weeks. It was transitioned over to the new styles that we had in the guide, and it took a minimum of fuss, which was really nice. So the guide itself is up on GitHub, and I invite you all to please go and have a look. If you'd like to see how difficult open source is, please have a look through the issues that you'll find on there. We've got about a dozen releases, and we tried to work really, really hard to make sure that our thinking and our working was shown in our changelogs as we went along. So I invite you to please go and have a look. And that's all from me. Danke, Alli.
Hello? Hey. Bloody hell, that's CSS Conf, everyone. Thank you. Did you have a good time? So at CSS Conf, we haven't talked about it all today, but we ran an opportunity program. And our opportunity program was where we would, with a little help from our sponsors, Envato and Thick, and a couple of people who made individual donations themselves, we raised enough money to send 14 people who couldn't have otherwise come to CSS Conf. And that's pretty badass. So big, huge thank you to Envato, Thick, and a couple of people. You know who you are. A huge thanks to all of our amazing orange shirt folks, wherever you are. If you want to slowly make your way up here, we'll do something fun. They're all going to rap. It's going to be a rap battle for us. Who here is coming? Who's coming tomorrow? Holy yeah. All right. Is anyone coming to Decompress on Friday? Okay, so if you're here, you can come to Decompress on Friday, which is going to be a really, really great event. If you thought this was good, just wait till Decompress. For the parties tonight, make sure you bring your lanyard, so just your name card, or else they won't let you in. We'll have a bouncer, and they'll be really like Collingwood about it. So just make sure you take it with you. There's going to be drinks, and there will be some finger food stuff there as well. As I said, if you have a partner, you want to bring them, please bring them. That's definitely fun. Where's Ben? Where's Ben? Hey, Ben. Do you want to come and take a photo of this fantastic group of people? Very good-looking bunch of folks. All right, so we do something at the end of a CSS Conf, which is kind of fun. We bring up these amazing volunteers, so thanks to them. Christina, you can come and join us too. Thomas, wherever you are. Our CSS Conf AU folks. Oh, Thomas had to go. He's lost. All right, where are you? Let's do a quick little photo. And then we're going to do something fun for everyone.
Not the front row.
Front row. Don't listen to Sharky.
Hello. Box, please.
All right, that was pretty fun. You thought that was fun? Now we want all of you to come and join us up here, and we're going to do the same thing. Leave your stuff where you are. It's fine. We won't have anyone steal it. Come and join us.
You want to shout out to the live stream? If you're watching it in the other room.
Oh, yeah, and if you're watching in the other room, I have to wait 30 seconds, and then you can come in. But you need to come in here, too.
Yeah, no, I think it's...
That's too hard.
It's load-bearing. Yeah, I wouldn't touch it. It's fine, it's fine.
Closest laptop.
We're going to have people standing around here. Yeah. So wait, you can't put a laptop here?
It slides off.
It slides off. Now, I haven't been in this room today. It's really nice in here.
It's good. It's nice and warm. It feels good. What do you want? Yeah, I enjoy this.
Bye.
It only holds 120 with 300.
Yeah.
They told me to take my shirt off. I mean, no, take my jacket.
They mean take your shirt off.
Yeah, they're like, take it off.
They meant it.
The live stream's still going, right?
Yeah.
Yeah, get Xavier to go.
Oh, they're
coming.
Quick, everybody.
Get him to go on the live stream.
Maybe come down in front, too.
Everyone from this side needs to work
All right, Ben. Everyone in on the right over there, yeah? More right. come on over. More on the left. I know this is odd, but we've done it every year. All right?
Come on, game, hurry up, Mike.
All right, Ben. All right, did anyone blink?
Yes.
No. All right, good. All right, good.
Hands up.
CSS and JavaScript. I don't know. What do we do?
All right, CSS is awesome.
CSS is awesome on 3.
That's
all right.
a long thing
Everyone
to
can say
shout.
awful if they like it.
1, 2, 3.
I tried really hard to make that person.
Should have gone with awful.
That was awful. That was awful. Yeah.
I
All
still
right.
miss you.
Everybody.
Pushing?
Someone's feeling me.
No, I think one person jumped. I think we may have Jackie jump.
All right. Hands up on 3. All right. 1, 2, 3. All right. You're all wonderful. Thank you so much.